Dear student, welcome to the nanotechnology lecture series. Today I am covering a very important type of physical vapor deposition technique, and this technique is known as cathodic arc deposition technique for thin films. So student, please note that cathodic arc deposition technique is a type of physical vapor deposition technique. Okay. So what do you think what the term physical vapor deposition mean? Physical vapor deposition technique is a technique in which a precursor material, a material which we want to convert into a thin film, is a precursor material. So in physical vapor deposition technique, a precursor material is evaporated, and when the precursor material evaporated, it is then transported onto the surface of the substrate. So substrate is a material on which we want to deposit a thin film. So the vaporized material, precursor material, is just transported onto the surface of the substrate, and then it is converted into a solid thin film. So this is known as physical vapor deposition. In a simple word, physical vapor deposition is a technique in which a precursor material is vaporized and transported onto the surface of the substrate, and then on the surface of the substrate, that vaporized precursor material is converted into a solid condensed thin films. So the cathodic arc deposition technique is a kind of same physical vapor deposition technique. Okay, but the difference in cathodic arc deposition technique is that in cathodic arc deposition technique, an electric arc is used to evaporate the precursor material. Okay, and the precursor material used in cathodic arc deposition technique is a cathode material. So in cathodic arc deposition technique, a cathode material is evaporated by an electric arc, and when the electric arc vaporizes the cathodic material, it is then transported onto the surface of the substrate, and in this way we get deposit a solid thin film on the surface of the substrate. So in a simple word, cathodic arc deposition technique is a type of physical vapor deposition technique in which we evaporate a cathode material with the help of electric arc, and then this evaporated cathode material is transported onto the surface of the substrate, and at the end of the day we get a thin film on the surface of the substrate. Okay, just please note that cathodic arc deposition technique is a essential part of the mechanical and as well as mining industry, but it is more frequently used in different types of mechanical tooling industries. So basically different types of mechanical tools are basically have films which are basically coated via cathodic arc deposition technique. Apart from the mechanical mining and mechanical tuning industry, cathodic arc deposition technique is also an essential part of the microelectronic industry. So in conclusion, dear student, cathodic arc deposition technique is a type of physical vapor deposition technique in which an electric arc is used to vaporize the cathode material, and the cathode material which is vaporized is transported onto the surface of the substrate, and then That vaporized material is condensed, is converted into a solid thin film. So dear student, please note that the good thing about the cathodic or deposition technique is that we can basically deposit broad range of material by using this technique. We can deposit metals, we can deposit alloys, we can deposit ceramics, and as well as we can deposit composites with cathodic deposition technique. So in a simple word, cathodic or deposition technique is diverse as compared to all other types of physical vapor deposition techniques available. So student, cathodic arc deposition is a technique in which a cathode vapor plasma is produced from high current, low voltage discharge between the two electrodes in a vacuum or in a low vapor pressure inert gas or in a reactive environment by introducing a reactive gas. The arc spot has a diameter around 10 raised to power minus 8 to 10 raised to power minus 4 meter and has a velocity around 10 raised to power has a velocity around 100 meter per second, carries a high current density around 10 raised to power 8 to 10 raised to power 12 ampere per meter square, erode the cathode by melting and vaporization, as well as particle ejection is then transported and deposited onto the surface of the substrate, result into a thin films. So in a simple word, dear student, first, cathodic arc deposition is a kind of physical vapor deposition technique. And in cathodic arc deposition technique, cathode acts as a precursor material. So in cathodic arc deposition technique, we basically deposit a cathode material onto the surface of the substrate. The cathode material is ignited by a very high energy plasma source, which is known as a plasma igniter. So plasma igniter ignite or evaporate a very small portion of cathode material. Usually the diameter of this small portion is around 10 raised to power minus 8 to 10 raised to power minus 4 meter. So basically the plasma igniter evaporate the very small portion of the cathode material, which has a diameter 10 raised to power minus 8 to 10 raised to power minus 4 meter, and that region of the cathode is known as cathode spot. So when the small spot of the cathode material is evaporated by a plasma igniter, due to the high energy of the high temperature of the plasma igniter, the spot of the cathode ignite, evaporated, and it is converted into a plasma, which is based on ion, electrons, and neutrals. These ions, electrons, and neutrals are directed by using a magnetic field setup or magnetic ring inside the cathodic arc deposition system, and then they are transported onto the surface of the substrate. And this cathode material, which is in the form of plasma, when it is transported onto the surface of the substrate, is condensed and it is converted into a thin film. Please, dear student, note that the plasma source or plasma igniter has a very high current density, and current density is around 10 raised to power minus 8 to 10 raised to power minus 10 raised to power 8 to 10 raised to power 10 12 ampere per meter square. This means that this due to a very high current intensity of the plasma igniter when it interact with a surface of the cathode, this cause a very high temperature, and due to a very high temperature around thousands of Kelvin, that result to convert a small portion of the cathode into a plasma, and then that is transported onto the surface of substrate and converted into a thin film. Just please note that the cathodic arc deposition technique is a widely used industrial technique. So it is a very important type, a very important technique used in tooling, mining, and mechanical industry. But it is also a very important part of microelectronic industry. Okay, so the cathodic arc deposition technique is one of the most industrial technique used, and it is suitable to coat a titanium nitride. Titanium nitride thin film coating are produced by cathodic arc deposition by producing a plasma of titanium cathode in the presence of low pressure nitrogen gas present inside the chamber, result into a chemical with titanium plasma form a titanium nitride thin films. So, dear student, in a simple word, this type of deposition of thin film is known as reactive cathodic arc deposition of thin films. Usually, in cathodic arc deposition technique, we deposit a material which is present as a cathode in cathodic arc reactive chamber. However, you can also do a chemical reaction inside the cathodic arc deposition reaction chamber. Like you can deposit titanium nitride thin films onto the surface of a substrate by using cathodic arc deposition systems. In depositing a titanium nitride coating onto the surface of the substrate using cathodic arc deposition systems, we usually use a titanium electrodes. Okay, these electrodes are ignited by a plasma igniter. Since I have previously discussed that the plasma igniter have a very high current density, and due to a very high current density, the titanium cathode, the small portion of the titanium cathode which is known as a cathodic spot, is converted into a plasma. So this plasma has a titanium ions, and in order to convert it into a titanium nitride thin films, the nitrogen gas is introduced inside the reaction chamber of the cathodic arc deposition setup. So the plasma ion which are based on titanium ions are interact with the gas which is introduced inside the reaction chamber of the cathodic arc deposition setup. So when the titanium ion react with a nitrogen gas, they convert it into a titanium nitride ions, convert it into a titanium nitride, and that titanium nitride is transported onto the surface of the substrate, and at the end of the day we get a titanium nitride onto the surface of the substrate, which is then condensed and converted into a titanium nitride thin films. So please note that the cathodic arc deposition technique is not just a simple type of physical vapor deposition technique of depositing a thin film directly onto the surface of the substrate, but it is also a reactive chemical cathodic deposition technique. So you can basically react the different types of react the cathode material with different types of gas, and you can form a complex material thin films onto the surface of the substrate. So this is a diversity of the cathodic deposition technique. So now let's just explain the difference between a cathodic arc deposition technique and a conventional physical vapor deposition technique with a schematic diagram. Okay, so please note that in normal cathodic arc deposition technique we have a cathode material, okay, like this. So this is a cathode material. The cathode material is a material in cathodic arc deposition which is converted into a thin films. So basically we transport a material from cathode onto the surface of the substrate and convert it into a thin films. So the cathode in cathodic arc deposition system is basically connected with a potential source. Okay, so this is connected to a negative terminal of the potential source. This cathodic arc systems have also a material, a substrate inside it. Okay, and substrate is also biased and it is connected with a negative terminal of the potential battery. Cathodic arc deposition system have an anode and it is somewhere. This is basically it is anode. It is connected to a positive terminal of the battery, so it is usually present somewhere inside the cathodic arc deposition system. Now, this is just a chamber of the cathodic arc deposition system. Okay, let me try it like this. Okay, so this is basically a chamber of the cathodic arc deposition. Now, dear student, the difference starts somewhere here. In cathodic arc deposition systems, we have an igniter in cathodic arc deposition system. So this is basically known as a plasma igniter. Plasma igniter have a very high temperature. So when this igniter interact with the surface of the cathode material, due to a very high temperature of the plasma arc, the cathode material is converted into positive ions, electrons and neutral atoms. Okay, so now these positive ion, electrons and neutral atoms are directed by different types of magnetic field setup inside the plasma arc deposition systems. I will explain comprehensively with a very accurate schematic diagram in further part of this lecture, but for simplicity of explanation I am explaining this handwritten diagram. So these positive and negative ion in cathodic arc deposition system are directed onto the surface of the substrate by a different ways. They are transported somewhere here and then they are in the form of a gaseous, okay, they are in gaseous form, which are basically converted into a condensed form, and then at the end of the day we get a thin film on the surface of the substrate in the cathodic arc deposition system. So now coming to a difference between So what is the difference in a conventional physical vapor deposition systems? Basically, listeners, please note that conventional physical vapor deposition systems have a precursor material and it has also a substrate material. This precursor material is connected with different types of heating source like a heaters, okay, and you can basically evaporate the precursor material either by a heating, which is usually a thermionic heating, or it can be converted by it can be evaporated by using an electron gun like this. Okay, it is directed onto the surface of the substrate, and when the electron gun is having a very high energy, or a resist or a heating or a thermionic heater, which is usually a tungsten heater, heat or the precursor material which you want to deposit is on the surface of this substrate, due to a thermionic heat or due to an high energy electron, the precursor material basically is just get evaporated and it is then transported onto the surface of the substrate material, and at the end of the day we get a thin film onto the surface of the substrate material. So the key difference is that in cathodic arc deposition system, we basically ignite a very small portion of the electrode, and after the due to an electric arc, the small portion of the cathode material get evaporated and it get ionized and form a plasma, and the material of the plasma is then transported onto the surface of the substrate, which is then deposited, solidified, and converted into a thin film. In a case of conventional physical vapor deposition technique, we have a precursor material which is heated either thermionically or either by a high energy electron, and due to the extremely high heat, this small portion of the precursor material is evaporated and it is then transported onto the surface of the substrate, and at the end of the day it is deposited and converted into a thin film. So interesting fact to notice here is that how you can distinguish the film which is coated by a cathodic arc deposition technique with other types of high vacuum deposition techniques. The student, what are the distinguished features of the films which we basically deposit with cathodic arc deposition technique as compared to the other types of physical vapor deposition techniques? Please note that the key fact which make a cathodic arc deposition technique unique as compared to the other types of physical vapor deposition techniques like electron beam evaporation technique or thermionic uh, evaporation techniques such as closed space sublimation, etc., is that in cathodic arc deposition technique we ignite, we evaporate a very small portion of the cathode, which is known as a cathode spot. So when we ignite, the temperature of the ignited spot or the temperature of the cathodic spot is in thousands degree of centigrade or Fahrenheit. So due to a very high temperature, we basically get a very high energetic ions from the cathode spot, and these high energetic ion with a high speed, when they interact with the surface of the substrate, we get a very strong interactive thin films. These thin films which are produced by cathodic arc deposition techniques are very hard as compared to the other types of physical or chemical vapor deposition techniques available for deposition of thin film. So the key distinguished feature of cathodic arc deposition technique is that the ion which are produced in cathodic arc deposition process have a very high energy, and their energy is around 10 to 100 electron volt, and due to this high energy we get a very strong coating. Another distinguished feature of cathodic arc deposition technique is that we produce highly uniform deposition of films by this technique, because with this technique basically the flux of ion is too much, so the larger area we can basically cover with a coating of thin films. So listeners, please note that though in cathodic arc deposition technique the uniformity of thin film is quite difficult, but there are different types of setup used in a cathodic arc deposition system through which we coat a very uniform thin films. Like in some cathodic arc deposition technique, the substrate material is moved, is rotated with a certain speed, so the evaporated material which is produced by a cathode spot basically just gets stuck uniformly over the whole surface. So there are different ways through which we basically deposit a material from the cathode spot onto the surface of the substrate uniformly. Another distinguished feature of cathodic arc deposition is that this technique produces a highly dense coating. So you basically get a very hard and dense coating due to a cathodic arc deposition. As I have previously discussed that the temperature of the spot is too much, and due to a high temperature the plasma ion which are produced have a very high kinetic energy, so they will interact with a surface of the substrate with a very high speed, and due to a very high velocity interaction of ion with the surface of the substrate they result into a highly dense coating. So this is the key distinguished feature of cathodic arc deposition film, that the films which are deposited with a cathodic arc deposition technique have a very highly dense coating. Another distinguished feature of cathodic arc deposition technique is that the film which we deposit with a cathodic arc deposition technique have a strong adhesion. Okay, they basically interact very strongly with the surface of the substrate, because the kinetic energy of the ions which are produced on the cathodic spot is very high, and due to very high kinetic energy they interact very strongly with the surface of the substrate, and due to this we basically the film which is produced by cathodic arc deposition technique is very strongly adhesive. Some of the common example of the strongly adhesive thin films produced by cathodic arc deposition techniques are metal carbide or nitride coatings. So metal carbides and nitrides coatings are commonly done by cathodic arc deposition technique. Another distinguished feature of cathodic arc deposition technique is that, student, please note that since the temperature of the cathode material is too much, and now this cathode material, if we have a substrate material at a room temperature, then the interaction of the high energy, high temperature cathode material or cathode ion with a substrate material will be not good. So in order to have a better interaction of a cathode material with a surface of the substrate, usually in the cathodic or deposition systems, the substrate is heated slightly above the room temperature. So when the substrate is slightly heated above the room temperature, this basically result into a diffusion or pseudo diffusion of the ion which are produced from the cathode spot, and this pseudo diffusion of those ions with the substrate material will result into a chemical reaction, and this chemical reaction will cause a strong adhesion and structural modification. So dear student, please note that in conventional physical vapor deposition technique, though they also heat a substrate, but it is very useful to heat a substrate slightly above the room temperature in cathodic arc deposition technique, because by heating a substrate during a process of deposition of thin film will cause a pseudo diffusion or a diffusion of the uh, evaporated ions from the cathode, and due to the diffusion of the ion from the cathode onto the substrate will cause a chemical reaction inside and on the surface of the substrate material, and which will result into a very strong adhesion and as well as structural modification. So in normal physical deposition techniques, you don't need to react a precursor material um, onto the surface with the substrate or inside the substrate. However, with cathodic arc deposition technique, since you know that the kinetic energy of the ions which are produced from the cathode spot is too much, and when they interact with a surface of the substrate and they chemically react with the surface of the substrate, so if the surface of the substrate is hot, they will basically cause a diffusion and pseudo diffusion, and at the end of the day they basically will cause a structural modification and better adhesion. Another distinguished feature of cathodic arc deposition technique is that you can basically deposit a wide range of stoichiometric compositions. Okay, so basically you can deposit metals, alloys, ceramics and composites with cathodic arc deposition technique. This technique gives you a diversity in depositions of thin films. You cannot use different types of vacuum based techniques for depositing a multi-alloys or multi-compounds or complex compounds, but this technique gives you a diversity that you can deposit a wide range of complex compounds. How? Dear student, you can deposit different types of complex material by using cathodic arc deposition techniques. As I have previously discussed, that you can use a reactive gas inside the reaction chamber of the cathodic arc deposition system, and when the material from the cathode is evaporated, it will interact with those gases like nitrogen, etc., and they will cause a compound which is then transported onto the surface of substrate. But another point to notice here is that you can also use multi cathodes. inside the cathodic arc deposition systems. Multi-cathodes mean that you can use 2, 3 or 4 different types of cathodes having a different materials. So, and at the same time you can basically evaporate, you can form a plasma of different materials by using a plasma igniters on all those multi-cathodes. And they usually, so as a result you will get a plasma of multi-ion inside the reaction chamber, which may be transported and reacted with different types of reactive gas present in the cathodic arc deposition chamber, and then it is transported onto the surface of the substrate. So in this way, dear student, you can deposit complex types of materials and their thin films on the surface of the substrate by using cathodic arc deposition process. Another distinguished feature of cathodic arc deposition technique is that you can retain a different types of composition of source material very difficultly as compared to the materials forming alloys. Okay? What is the reason why you can deposit, though you can deposit different types of chemical compound, but still it is difficult to deposit compound in an accurate stoichiometric ratio as compared to the alloys. Dear student, please note that since I have previously discussed that the energy of the plasma igniter is too much, so when the plasma igniter interact with the surface of the cathode, it can basically produce a rush of the ions. So the speed of the ion is too much. Due to this, you cannot control accurately the transportation of ion onto the surface of the substrate. And that's the reason it is a drawback of the plasma of the cathodic arc deposition technique, that you can basically, though you can deposit different types of compound, but still you cannot control in accurate fashion the stoichiometric ratio of the deposited compounds. However, you can produce an accurate analysis by using cathodic arc deposition. So this is a main drawback, and that is a reason which limit the cathodic arc deposition technique into a microelectronic industry. Another distinguished feature of cathodic arc deposition is that uniformity of the deposited thin film is quite difficult. You can deposit a uniform thin film over the larger area of the subject, but still it is very difficult to make a uniform thin film by using cathodic arc deposition, because the energy or the flux of the ion is too much. Though if you can control the flux of ion in cathodic arc deposition, then there is a possibility to deposit uniform thin film, but still the flux of ion may cause a problem in uniformity. Okay. Dear student, another distinguished feature of cathodic arc deposition technique is that it is a very high evaporation technique. So basically the energy you can basically deposit a very thick film in very small amount of time, because the energy of the flux of ion, or the kinetic energy of the flux of ion, is too much. So due to a higher flux of the ion, we basically get a coating, a thick coating in a very small amount of time. Usually you can deposit thin film of thickness around 200 nanometer in 1 minute. So this is a plus point because high vacuum based techniques deposit a thin film of few nanometer in large amount of time. However, in cathodic oil deposition technique, since the flux of ion is too much, and due to this we can get a thicker film in few minutes. So this technique is suitable for depositing a thick film in a limited amount of time. Another distinguished feature of cathodic oil deposition technique is that this technique has an ability to deposit extremely hard adhesive thin films. Okay, so this technique basically deposit extremely hard adhesive thin film because of the high kinetic energy of the ion which are produced from the cathodic spot. And the diversity of this technique is that due to a reactive processing we can also get a complex types of compounds. So basically we get two things at the same time. We can produce extremely hard adhesive coating, which is very important for especially for microelectronic, mechanical and tooling industry. And apart from this we can also produce a complex types of materials by using a reactive processing. So this is another distinguished feature of cathodic oil deposition technique is that we can deposit refractory materials by using cathodic oil deposition process. Refractory materials are the materials which are resistant to heat, pressure and chemical attack, and they can retain their strength at very high temperature. So it is very difficult since the refractory materials have ability to retain their strength at a higher temperature, then it is very difficult for other types of available physical vapor deposition techniques to evaporate them and deposit them as a thin film onto the surface of the substrate. But this can be done by cathodic oil deposition process. Since, dear students, you know that the temperature of the current of the plasma igniter which we use in cathodic oil deposition to evaporate a cathode material is too much. So due to a very high current, when the plasma igniter interact with refractory materials which have a very high temperature retaining ability, since the current of the plasma igniter is too much, that create a very high temperature on the position which is known as a cathode spot, and due to this high temperature the refractory material just get evaporated and it is transported onto the surface of the substrate as a thin film. Dear student, please note that the refractory materials are usually exist in form of polycrystals, polyphase. They are usually inorganic and non-metallic, and in some types of refractories are porous and as well as heterogeneous in the chemical composition. Common example of refractory material is silicon carbide, okay, and as well as zirconium carbide. Other example of refractories are silicon dioxide and aluminum. okay, aluminum oxide. So dear student, please note that the deposition of silicon carbide, zirconium carbide, alumina or silica is difficult because of their high temperature retainability due to their high temperature strength, but their deposition is done by a cathodic deposition process because this technique produces a very high temperature at cathode spot, which is even more than the temperature which is required to evaporate the refractives, and due to this, at the end of the day, we get refractive materials, they film onto the surface of the substrate inside the cathodic deposition chamber. Another distinguished feature of cathodic deposition process is that this process is very difficult in order to control the uniformity of the thin films, because as I have previously discussed, the kinetic energy of the ion which are produced at cathode spot is too much, and due to a higher kinetic energy, the uniformity of films which are formed from the cathode ion is difficult. So there are different types of setup which are used in order to make it possible to get a uniform thin films inside the reaction chamber. Usually the substrate material is rotated, so uh, we get a better uniformity onto the surface of the substrate. So this is basically a disadvantage of cathodic deposition technique, which limit the cathodic deposition technique in microelectronic industry. Another distinguished feature of cathodic deposition technique is that in situ control of evaporated thickness is problematic. Okay, you cannot control a thickness of the film inside the reaction chamber of cathodic deposition setup. It is very difficult to control the thickness of layer in cathodic deposition setup because the kinetic energy of ion which are produced from cathode spot is around 10 to 200 electron volt, and due to the high kinetic energy of those ions, you basically get a film deposited onto the substrate surface abruptly in no time, and this make in situ or internal control of the size of the thin films difficult. Okay, so this is a drawback of cathodic deposition. You cannot basically control the uniformity of the thin films, and also you cannot control the thickness of film onto the surface of the substrate. So the key point to notice here for researcher is that, dear students, you basically need to rotate a substrate. So when you rotate a substrate, at least at the end of the day, you will get somehow uniform thin films. However, the thickness of the layer still will be a problematic in cathodic deposition process. Another distinguished feature, which is basically a drawback of cathodic deposition technique, is that there are usually form a drop onto the surface of the substrate, and due to those droplets, the uniformity of the film is disturbed. So the student, the presence of the small drops in the ionized vapor of the cathode material cause a drawback or defect in the structure of the films. And so you need to avoid those types of droplets onto the surface of the substrate by arranging the setup of the substrate in a different ways. So this is the main drawback. Okay, so you can basically get a small types of different circular, square, or different types of shapes of droplet onto the surface of the substrate of the cathodic or deposited thin films. So you need a special types of arrangement during a processing in order to avoid those droplets. So now let dear student explain the cathodic or deposition systems in a brief. Like what are the essential part of the cathodic or instrument which is used in industry. Dear student, please note that the cathodic or deposition system consists of metallic electrode. Okay, please note that the cathodic or deposition system consists of metallic cathode. The student, please note that it's not necessary that the cathodic or deposition system have a metallic cathode. It may have a composition of different types of metallic alloys, and also it may be in combination of different types of composites. So however, in general cathodic or deposition system, the cathodic or deposition systems have a metallic cathode. Now the role of metallic cathode is very important. Metallic cathode or a cathode in cathodic or deposition system act as a precursor material. So basically in cathodic or deposition system, we or industrialists deposit the cathode material onto the surface of the substrate. So cathode in cathodic or deposition system act as a precursor material. Okay, please note that the cathodic or deposition is a very wide process. So wide categories of cathode material are used in cathodic or deposition, like titanium, chromium, nickel, cobalt, silicon, zirconium, etc. So it is a very diverse technique. So due to this, the cathode used in cathodic or deposition may be made of various wide range of categories of material. If let's say if we want to produce a single phase thin films with a specific single elements, so in that case we need a single type of cathodes like titanium cathode, chromium cathode, nickel cathode, etc. However, in case we are depositing aluminium chromium alloy or aluminium nickel alloys or different types of compositions of alloy, then in that case we need cathodes of different types of alloys, and same case is applied for refractory metals or refractory elements like chromium, like zirconium, silicon, etc. Okay, so it's depend that what kind of material we want to deposit at a thin film, and on the best of that requirement we use different types of cathodes. Okay, so this make the cathodic or deposition is the diversity of the cathode make the cathodic or deposition diverse. The second important part or important component of cathodic or deposition is anode. Student, please note that in cathodic arc deposition, usually anode may be used as a target material. However, uh, they are used as a component of creating a potential difference, and separate target material, uh, which is known as a substrate, is used in cathodic arc deposition system. So it's depend. However, in many cases or more frequently, anode is not used as a target material, but it is used a potential difference creation material, okay, in the cathodic arc deposition. Another essential component of cathodic arc deposition is magnet. So now I have briefly explained before that in cathodic arc deposition process, the plasma arc igniter basically create in high energetic plasma at cathodic spots. Cathodic spot is a very small pot of diameter 10 raised to power minus 4 to 10 raised to power minus 8 meter on the cathode. So plasma arc igniter, which has a very high current, basically ignite the small portion of cathode, which is cathodic spot. So that portion basically, when it is ignited by a plasma igniter, that small spot is converted into highly energetic ions and highly energetic plasma, which is basically a combination of ions, electrons and neutrals. These ions have this plasma, which is created by the plasma arc igniters, have a very high temperature and kinetic energy. So this plasma need to be directed onto the surface of substrate if we want to make our cathodic arc deposition successful. So in order to direct the ions which are basically present in a plasma onto the surface of substrate, we need magnetic coils or magnetic field. Dear student, please note that the plasma which is generated uh, in the cathode at cathodic spot is basically have a proton, have an ions, electrons and neutrals. The electrons are transported or being collected at the anode. However, the ions need to be deposited onto the surface of the substrate. So this the magnetic field is basically is a combination so the magnetic field which is present inside the cathodic arc deposition, the ion will interact with magnetic field, and due to the magnetic field the ion will be deflected and transported onto the surface of the substrate. I think if you have a little bit understanding about physics, according to Lorentz law, the electric charges feel a magnetic field when they pass through the magnet. So the electromagnetic wave is basically a combination of electric field and as well as magnetic field. So when the ion travel in the magnetic field, they will have magnetic and as well as electric component. So those ion will act as an electromagnetic waves, and due to electromagnetic waves, ion will spiralate inside the cathodic arc deposition systems, and due to spiralation they will be transported onto the surface of the substrate where they will be deposited as a thin films. So dear student, the role of the magnetic component in cathodic arc deposition system is very important. They basically transport the ion from the cathodic spot onto the surface of substrate, and the end of the day the transported ion onto the surface of substrate are converted into thin film. Another essential component of cathodic arc deposition system is plasma arc igniter. The student, plasma arc igniter is very important component of plasma of cathodic arc deposition, and this is a reason which differentiate cathodic arc deposition system from other physical vapor deposition systems. In other physical vapor deposition systems like electron beam evaporation system, the electron beam is used to evaporate a precursor material. In closed space sublimation systems, thermionic emission is used to evaporate precursor material. However, in cathodic arc deposition system, plasma arc igniters are used to evaporate a precursor material, which is a cathode material. Okay, please note that these plasma arc igniters have some specific properties. So basically the plasma arc igniters have a very high electric current in it, and it has like this highly it has a flux of electric current, which when fall, or which when interact with the cathode, it's just basically create a very high temperature and convert the cathode material into a vapor material. So dear student, please note that the cathodic arc igniter has a very dense flux of ions or flux of current, which basically heat the cathode material up to thousands of degrees of centigrades. So this make the cathodic arc deposition process unique, because you can heat the cathode material up to 1000 degrees of centigrades, and due to this we can basically even melt and even evaporate the refractory materials which have very high melting temperature. So this plasma arc igniter make cathodic arc deposition process universal. Another important setup used in cathodic arc deposition system is reactive gas. So there are usually different types of valves used in cathodic arc deposition process, in which reactive gases are incorporated inside the reaction chamber. So like as I have previously discussed, that you can use cathodic arc deposition process to deposit a single elemental material like titanium, chromium, nickel, cobalt. However, you can even diversify the cathodic arc deposition process by depositing different types of compounds by introducing reactive gases. Like if you want to produce a if you want to produce titanium nitride, okay, in that case the titanium cathodes are used as a cathodic material in cathodic arc deposition reaction chamber. However, nitrogen gas is introduced as a reactive gas. So when the cathode of titanium is ignited by a plasma igniter, the cathode evaporate the titanium ions, which react with nitrogen gas, and at the end of the day they are converted into titanium nitride, and then they are transported onto the surface of substrate and deposited as a thin films. Similarly, you can also, dear student, prepare silicon oxide based thin film by using silicon as an electrode and oxygen as a reactive gas. And you can also produce a silicon carbide by using reactive uh, uh, gas systems inside the cathodic arc deposition system. So basically the reactive gases which are introduced through a wall are also important in cathodic arc deposition system in a way if you want to produce a complex material. Okay, another essential part of cathodic arc deposition system is vacuum pump. The student, vacuum pump are very important because, dear student, if the uh, if the pressure inside the reaction chamber of cathodic arc deposition system is high, then the mean free path between the ions which are present inside the reaction chamber during the cathodic arc deposition process will be less, and due to this ion will collide with each other, and they will never reach to the surface of the substrate. So in order to transport the cathodic material onto the surface of the substrate without any collision, without any impurity, or without any chemical reaction inside the reaction chamber, the vacuum pumps are used to evacuate the reaction chambers. The student, please note that usually the vapor pressure or the vacuum pressure used in cathodic arc deposition system is in the range of 10 raised to power minus 4 to 10 raised to power minus 6 torr. So, dear student, keep this in mind that for any type of vacuum deposition system, if you want to prepare highly pure thin films without any kind of impurities, you need to introduce a vacuum pump, and you need to take the vacuum very low and up to around 10 raised to power minus 4 to 10 raised to power minus 6 torr. Different types of vacuum pumps are commonly used in cathodic arc deposition systems like turbomolecular pump, mechanical pumps, rotary pumps, etc. So and in some cases you can also use diffusion pump, but diffusion pumps has an issue of oils. Basically they evaporate molecules of oil which can at the end of the day which can basically produce impurities on the surface of the substrate. Another important factor to notice is electric potential which is used in cathodic arc deposition system. Please note that the cathode is basically cathode is connected in cathodic arc deposition system with a negative terminal of the potential, and similarly the anode is connected to the positive terminal of the potential system in the cathodic arc deposition system. Dear student, please note that we also need a potential source for substrate, because we in cathodic arc deposition we require a node to be transported onto the surface of the substrate. So the substrate is connected with a negative bias terminal, because the ion which will be transported onto the surface of the substrate have a positive charge, so they can be easily attracted by negatively charged substrate. So so the student, we need different types of potential sources, a different connection of potential system, different types of connection of our potential batteries. First connection is usually required in cathodic arc deposition. Connection is required with cathode, whereas in the second connection is required to an anode which is connected to the positive terminal, and similarly the third potential is applied, or third battery is connected with a substrate material, and it is made negatively polarized. So in this way, a positive ion may be easily transported onto the surface of the negatively biased substrate. So now let us briefly explain a cathodic or deposition system with a schematic diagram. That what are the part of the cathodic or deposition systems? What are the essential component of the cathodic or deposition system by a schematic diagram? The cathodic or deposition system consists of a reaction chamber. Inside the reaction chamber there is a cathode. Cathode is a material which acts as a precursor and which is usually evaporated in cathodic or deposition process and then is transported and deposited as a thin film. The cathodic or deposition system consists of a substrate. The substrate is a material is made of a material on which the cathode, which is material which is evaporated, is deposited. So the substrate, the thin films are basically deposited onto the surface of the substrate. Cathodic or deposition system consists of a magnetic coils. Basically, the magnetic coils play very important role. So when the cathode spot is produced onto the surface of the cathode, this spot may move throughout the surface of the cathode and it may go even away. So in order to confine the cathode spot onto the surface of the substrate, magnetic coils are basically also incorporated near the cathode to control the cathode spot onto the surface of cathode. Okay, this cathode is connected with anode, and they are connected with the help of insulation. Okay, so this is cathode, the bluish one, and the yellow image part of the image represent an anode, and both the cathode and anode are connected by insulator. Students, please note that the cathode is connected with negative terminal of the potential source. So this is a battery, and the cathode is connected with the negative terminal of the potential source, whereas anode is connected to the positive terminal of potential source. So due to difference in positive and negative terminal of the potential source, there will be create the potential difference between the cathode and anode will be created. Dear student, another interesting fact to notice here is that the substrate material is also connected with potential source. The negative terminal of battery is connected with substrate material. The reason of making a substrate material negative is that during the cathodic or deposition process, we produce a spot onto the surface of this cathode. So this spot is a combination of ion, electrons, and neutrals. So the spot is basically a plasma, and we need ions from this cathode to be transported onto the surface of the substrate material. So ions have basically a positive charge. So when the substrate is connected with a negative terminal of battery, the ion can be easily transported onto the surface of the substrate due to their positive charge. And similarly, electrons which are not required in our cathodic or deposition process are deflected toward the anode surface. Okay, So, distant, please note that the vacuum, low vacuum is very important for cathodic ore deposition. So these two signs or symbols are basically representing a pumps which are used in cathodic ore deposition process. As I previously discussed, uh, low vacuum create a longer mean free path, and due to a longer mean free path it is easy to transport the plasma, or it is to transport the ion from the cathode spot onto the surface of the substrate without any collision between these ions, and at the end of the day we basically get uniform thin films. The student, please note that the vacuum pressure used in cathodic ore deposition process is in the range of 10 raised to power minus 4 to 10 raised to power minus 6 star. But it's depend on the process. Okay, if you want to prepare thin film with high level of purity, the vacuum pressure may be decreased up to 10 to the power minus 8 torr or even more. But it's depend on the combination of the vacuum pumps which are used in cathodic ore deposition process. Most commonly used vacuum pumped in cathodic ore deposition processes are rotary pumps, turbomolecular pump, and in rare cases diffusion pump are also used. Okay, and there may be used a combination of turbomolecular pump, rotary pump, or mechanical pump. So it's depend on the processing requirements. It's depend on the nature of thin film you want to prepare. You can adjust the combination of vacuum pump used in cathodic ore deposition process. The important component of cathodic ore deposition process is electric igniter or plasma arc igniter. Dear student, please note that plasma arc igniter make the cathodic ore deposition process universal, because this plasma arc igniter create a very high temperature, temperatures in 1000 degrees centigrade onto the surface of the cathode, and due to this high temperature you can basically use any kind of refractory metals or any kind of complex material with high melting temperature, and that material can be easily converted into a plasma and into a plasma. So in this way basically you can mm, deposit even refractory metals like zirconium, uh, silicon, etc. by using a plasma arc igniter. And this plasma arc igniter make the cathodic ore deposition uh, different than the normal physical vapor deposition processes. So, dear student, this is just an overview of the cathodic ore deposition systems. Okay, so in a summary, basically cathodic ore deposition system consists of a reaction chamber. Okay, inside the reaction chamber in cathodic ore deposition there is a cathode which is connected with anode with the help of insulation. Okay, the cathode spot usually reside onto the surface of the cathode. So in order to confine the cathode spot onto the surface of the cathode, magnetic coils are is used. Okay, and these magnetic coils, due to their magnetic field, they interact with the ion of and electrons of the cathode spot, and which compel them to reside in the on the surface of the spot. Okay, and both the cathode and anode in cathodic arc deposition systems are connected with the positive and negative terminal of the potential source. Okay, the students, similarly, the substrate material is connected with uh, electrode of the potential source. So the electrode, the substrate material is connected with the negative terminal of the potential source. So the negative terminal make the substrate surface negatively biased, and due to this, the ion which will be created with the help of the plasma igniter or may be easily transported onto the surface of the substrate material, and at the end of the day we get thin films. The student, the vacuum pumps are also used in cathodic arc deposition system, because the vacuum pump uh, avoid they basically decrease the pressure up to 10 to the power minus 4 to 10 to the power minus 6 torr, and due to this the collision between the plasma ion which are created in seduction chamber with the help of cathode spot is avoided. Okay, so they avoid the collision. The student, please note that the temperature of this cathode spot is the cathode spot on the cathode is very high. Due to the very high temperature of cathode spot, whole cathode just heat up. So we need a cooling system in cathode arc deposition system. So this is basically a cooling system which is usually composed of a water setup is circulated near or close to the cathode. So uh, with the cooling system, the temperature of the cathode is decreased, and in this way, if we have a cooling system, we like with the cathode, the surface of the cathode will the damage of the surface of the cathode is decreased. So cooling system of the cathode in the cathodic or deposition system is also important. Okay, as I have discussed that the plasma arc igniter basically produce a cathode spot. The cathode spot travel throughout the surface of the cathode, so the whole surface of the cathode heat up, and the circulation of the cooling water basically near the cathode decreases the temperature of the cathode. So in this way, the defects, if there is a possible due to a very high temperature of the plasma igniter, is avoided. So this is just an overview of the whole cathodic arc deposition system. So student, in cathodic arc deposition system, since you know that we use plasma arc igniter. Okay, so this plasma arc igniter, when interact with the surface of the cathode material, cathode is a material which we want to evaporate, so the temperature of the arc igniter is in thousands degree of centigrade. Okay, so this means that the arc which is produced by a plasma arc igniter operate around 10,000 degrees centigrade to 3,000 degrees centigrade. Dear student, keep this in mind. It's depend on the requirement of the substrate material. It's depend on the melting temperature of the substrate material. We can adjust the plasma arc igniter temperature. So this is just a key information for, especially for research student. Like if you are using a cathode material having a slightly lower melting point, then you can adjust the plasma arc igniter temperature slightly lower. However, in case if you are using a cathode material having a higher melting point, the plasma arc igniter with a higher temperature may be used. So it's depend on the researcher or industrial requirement. You can adjust the type and quality of the plasma arc igniter. Okay, the temperature of the plasma arc igniter will depend on the uh, will depend on the nature of gas which is ionized inside the plasma arc igniter system, and also the potential used between the cathodes in the arc igniter system. So the higher potential difference will cause a generation of a stream of plasma having a very high temperature. Okay, so when the plasma interact, or when the plasma or when the arc form of the plasma interact with the surface of the cathode material inside the cathodic arc deposition system, will result into a creation of cathode spot, and this cathode spot will be a form of a vaporized material in a very small region of the cathode spot, and this vaporized material will be a combination of a plasma which is created at the spot of the cathode is basically a fourth state of matter. Okay, it contains portion of a charged particles, ions or electron, and it may also contain neutral atoms. Okay, these and also some excited atoms of the cathode material. Now, is according to a basic physics, the magnetic field which is used in cathodic arc systems have north and south pole. So this is just an important information for you guys. The magnetic field which is used in cathodic arc deposition system or any type of magnetic field systems have a magnetic field of lines, and these magnetic field of lines appear from north pole to a south pole of the magnet. And interestingly, the electrons are attracted or they may be deflected, and similarly the proton or ions are also deflected by the magnetic field. So when the magnetic field is used in cathodic arc deposition system, they result into a deflection of the charged particle, just like this. This line basically represents the deflection of the electron toward the anode. Since you know that anode has a positive potential, okay, so they will attract the electron. However, we have used magnetic field in cathodic arc deposition system, so they will slightly deflect and confine the deflection of electron onto the surface of the cathode. And similarly, dear student, there will be a creation of the plasma inside the whole chamber of the cathodic arc deposition system, and plasma will be a combination of electron, protons and neutral atoms. Okay, so now is due to the electron and also different types of plasmas created inside the cathodic arc deposition system, they will result will also result in the interaction of if there is any gas present inside the reaction of the cathodic deposition system. So they will further create different types of wide range of ion inside the reaction chamber of the cathodic deposition systems. So in a simple word, student, initially the plasma arc igniter produce cathode spot here on the cathode material. Okay, now this spot on the cathode basically contain different types of ions. This means that it contains a plasma which is based on fundamental charge particles like ions, electrons, and neutrals or excited atoms. Okay, so they basically, especially the electrons, have a higher energy, and similarly ions and also other particles have higher energy, but the electron is lighter and it will have a more high energy than the ions and other neutrals or excited atoms. So these ions are these ionized particles, electrons and neutrals have higher energy. They will, if there is a present any other kind of gas inside the reaction chamber of the cathodic deposition system, the ions, excited atoms and an electron will also collide with them, and they will result into an ionization of the gas present inside the reaction chamber. So as a whole, you will get a plasma of wide range of different kinds of ions, electrons and excited and neutral atoms. Okay, so let's see. Now this schematic representation basically represents that the electrons or neutrals atoms, when they interact with the gas which is present inside the reaction chamber of cathodic deposition systems, they basically ionize the gas inside the cathodic deposition system. The ionized gas have neutral atoms like these. It will also contain an electron and as well as the protons or ions. These ions will be attracted toward the cathode material. Okay, since you know that cathode material which we want to deposit as a thin film has a negative potential, so the ionized ion from the gas which is present inside the chamber will be interacted toward the surface of the cathode material. This will result into a collision of this cathode material, and this will further erode or this will further remove the cathode material from its surface because of the collision of those ions. And similarly, the neutral atoms will travel as a whole inside the reaction chamber of the cathode deposition system. So now, student, you have to notice that the neutral atoms which are produced inside the reaction chamber, and similarly the positive ions which are also present inside the neutral chambers, they basically will interact with the surface of the cathode material, and they will result into a region of the cathode material. So now when the cathode material is being irradiated due to a bombardment of the different kinds of ion and as electron, the eroded material will then be transported in form of different kinds of ions, and it will be transported onto the surface of the substrate. So please note that in cathodic deposition systems, you are not only depositing an ion on positive ion onto the surface of the substrate material, but you are also depositing a neutral atoms, and at some time you may have an excited atoms. But please note that the potential which is used in a substrate material is negative. So the substrate in cathodic Hall deposition system is connected with a cathode of the potential source. So due to a negative nature of the cathode, the positive ions will be attracted onto the surface of the substrate. So this basically will result into a deposition of the desired material onto the surface of the substrate. Similarly, the electron will be transported onto the surface of the anode material, and it will be confined by a magnetic field which will cause a deflection of ion at the specific position of the anode. Another interesting fact to notice here is the confinement of ion onto the surface of the substrate. Like how we basically confine the ionized cathode material onto the surface of the substrate. This is done in two ways. One type of method is basically known as a magnetic confinement of a ions onto the surface of the substrate. Basically, dear student, please note that at advanced level in cathodic arc deposition system, variable magnetic field strength are used inside the reaction chamber of the cathodic arc deposition system. So the variable magnetic field are adjusted somewhere around the somewhere in the reaction chamber. So this magnetic field will interact with ions which are present inside the reaction chamber, and they will basically deflect at the ions which you want to deposit at a specific angle on the surface of the subject. And so in this way, distant, first you may confine the ion onto a specific position of the substrate. Secondly, you can get a better uniform thin films by using a magnetic field confinement onto the surface of the substrate. So magnetic field confinement is not only done to confine a cathode spot in a cathodic arc deposition system, but it may also be used to confine the ionized material or ionized cathode material onto the surface of the substrate. Okay. Another interesting fact to notice is the cooling setup, because the ions which basically interact with the surface of the substrate have very high energy. It's in thousands of electron volts and even more. So due to a higher kinetic energy of those ions, we also need a cooling system around the cathodic around the substrate. And basically, just please note that different types of water lines or watering systems or secondary gases are used to cool the substrate. However, this type of setup is done at advanced level, especially at industrial level. Okay. So dear student, plasma arc igniter is a machine. It is an instrument which utilizes the compressed air or compressed gases. Okay, plasma arc igniter utilize the compressed air and or compressed gases These include nitrogen, etc. And these gases are ionized and plasma is created. Typically, the gas are fed through the back of the machine, go into the system, and when they contact with electrode functional at high potential, they get ionized and create too much pressure. As soon as these gases build too much pressure and ionize, they are pushed out as a stream or a column of highly energetic pure plasma. And at the finest point, plasma temperature is extremely high, which create an cathodic arcing. So let's explain this in simple word. How the plasma arc igniter works. Basically, dear student, plasma arc igniter has a complex compressed gases. Okay, so the gases are incorporated in plasma arc igniter system through outside of the plasma arc igniter chamber. Okay, they are introduced, they are fed from outside inside the plasma arc igniter instrument. The plasma arc igniter instrument has electrodes. These electrodes are functional at high potential. So high potential is applied across the electrodes which are present in plasma arc igniter instrument, and at the same time gases which are very compressed are incorporated inside the plasma arc instrument. Okay, so when the gases are incorporated and they reach onto the surface of the electrodes which are present inside the plasma arc igniter instrument, the potential of the electrode is very high. Due to very high potential, the compressed gases get ionized inside the plasma arc igniter system. So the compressed gases are converted into their plasmas. This means that when the compressed gases interact with electrodes inside the plasma arc igniter system, those compressed gases are converted into electrons, protons, and neutrals or excited atoms. Okay, now the plasma arc igniting system has a huge range of ionized gases inside the igniter system. These gases are channelized through a very small hole which is known as an orifice. Okay, and when they pass through a very small region or very small point, the plasma appear as a stream or a column, okay, having a very high pressure and temperature. So when they pass through orifice, which is very a small hole or a very small part of the instrument, and when they pass through that part, the pressure and the temperature of the plasma reach up to its maximum, up to thousands degrees of centigrade, and in this way the plasma, a stream of plasma is basically taken out from the instrument, which is then used in cathodic arc deposition and as well as plasma arc welding, etc. Okay, so dear student, in a simple word, plasma arc igniter use very high potential electrodes, and in that system the gas which is compressed is incorporated, and when those gas interact with the electrode inside the plasma arc igniter system, they result into an ionization and they form a plasma which is then extracted out as a stream or as a column of a pure highly energetic plasma through a nozzle or through a very fine point, and which result into a high temperature and very high pressure of the plasma, and that plasma and then used in potential applications in microelectronics industry, welding industry, and as well as thin film industry. So now dear student, let's make the topic very simple. Basically the student, plasma arc igniter system, what do you think, what are the possible parts of plasma arc igniter system? So I will briefly explain that what are the key basic parts of plasma arc igniter system by a schematic diagram. Please note that dear student, the plasma arc igniter system consists of a cathode. Okay, so the cathode in plasma arc igniter system is connected with negative terminal of direct current potential source. Okay, so this cathode is basically in plasma arc igniting system is connected with negative potential of direct current potential source. Dear student, what do you think why we need a direct current potential source in plasma arc igniter system? Basically, why we don't use AC potential source in plasma arc igniter system? The reason of using a direct current potential source is quite simple, because direct current potential source or direct current batteries are very efficient. Okay, they give full potential to the electrode material. Okay, now the plasma arc igniter system consists of nozzle. Okay, the nozzle has a very small portion, and that portion is known as orifice of the nozzle, or it is basically a small hole, or it is a thin part of the nozzle. So please note that this small hole or this small orifice in plasma arc igniter system is very important, because the small stream of fine stream of the plasma will when it will pass to this small orifice, this will result into a very high temperature because of the very high pressure. Okay, so and in this case, so due to this, basically the plasma at the orifice, which is basically extracted from at the point of the orifice, is further used in technological application. Okay, so the cathodic, so the plasma arc igniter consists of a cathode which is connected to a negative terminal of the direct potential source, and the cathode is surrounded with a little bit space by a plasma arc igniter nozzle. Okay, the nozzle please note that the nozzle of the plasma arc igniter is connected with positive terminal of the direct current potential source. So the nozzle acts as anode in plasma arc igniter, whereas the cathode is present inside the nozzle at a small distance, and it acts as a negative potential source. Okay, dear student, please note that the temperature of the system usually in plasma arc igniter become too much. So in order to decrease the temperature, cooling setup is used across the plasma arc igniting system. Usually the cooling setup is composed of water, but there are also different types of secondary gases which may be used to cool the electrode of the plasma arc igniters. These secondary gases may include nitrogen, helium, etc. However, most commonly the cooling gases, or most commonly the cooling material used, or the cooling channels used in plasma arc igniting systems are based on water. Okay. So now, dear student, the nozzle of plasma arc igniter is connected with positive terminal of the direct current potential source, whereas the cathode is connected with negative terminal of the potential source. The potential between the cathode and the anode, which is basically a nozzle of the plasma arc igniter, is too much. Usually in plasma arc igniter system, the potential operate in thousands of volts. Okay, so when the potential between the electrode and cathode is too much due to a difference of potential between the cathode and anode, they will cause a spark, or they will cause an arc at the tip of the cathode. So dear student, please note that this arc has a very high temperature and it has a very high current. So when an external gas is incorporated in plasma arc system like this, so these arrows represent an external gas which we want to ionize in plasma arc igniter. When it is incorporated inside the plasma arc igniter systems, okay, the arc, which has a very high potential at cathode, will result into the ionization of the incorporated gas. Okay, so when the external gas interact with the arc, which is operating at very high temperature, thousands degree of centigrades, okay, so when it interacted, they result into a formation of plasma inside the plasma arc igniting system. Okay, so the plasma is formed between the cathode and anode, or between the cathode and nozzle of the plasma arc igniting system. So this plasma has a very high temperature and as well as pressure. When the plasma reach to the nozzle, to the tip of the nozzle, which has a very small orifice, the orifice is usually is in few millimeter. So when they pass through this orifice, the temperature and as well as the pressure of plasma due to a narrow region or due to a thin region will further increase. Okay, so this means that when the plasma pass through this orifice, the temperature of the stream of the plasma, or the temperature of the directed plasma, will reach up to thousands degrees of centigrade. Dear student, please note that usually the temperature of the plasma when it passes through the orifice reach around 10,000 degrees centigrade to 30,000 degrees centigrade. Okay, so the stream of the plasma will basically pass through a small orifice of the plasma arc igniting system. So in this way, basically we produce a plasma from the plasma arc igniting system, and this plasma has a very high temperature. So dear student, please note that in this way, basically dear student, please note that this stream of the plasma, which has a very high temperature and as well as a pressure, will further be used in welding, which is known as plasma arc welding, and it may be used in different types of microelectronics application, including cathodic arc deposition. So now let's explain this, that how this stream of the plasma may be used in cathodic arc deposition systems. Dear student, please note that the cathodic arc deposition system, as I have previously discussed, that it has an electrode, which it has a cathode, which acts as a precursor material. Usually, the material from the cathode is extracted and it is transported onto the surface of the substrate, and then it is deposited onto the surface of the substrate in cathodic arc deposition systems. So, the student, the cathode usually used is metallic in cathodic arc deposition systems. So now, as I have previously discussed, the temperature of the stream of the plasma is in thousands of degrees centigrade. So basically you can melt refractory metals, you can melt any type of metals from which cathode material is made. So this makes cathodic arc deposition process very diverse because of this plasma arc. So when the stream of the plasma arc from the plasma arc igniter interact with the surface of the cathode material in cathodic arc deposition system, they will result into a melt of the very small region of the cathode in cathodic arc deposition system. This small region or small part of the cathode which is melted and converted into a vapor of plasma is known as cathode spot. So in cathodic arc deposition process, highly energetic plasma from the plasma arc igniter, when interact with the surface of the cathode material, they will result into a small region of cathode material to be evaporated and converted into a plasma, which is a composition of ions, electron, and as well as neutrals. Okay, so now interesting point here to notice is that the cathodic arc system, when a small region of the cathode is converted into a cathodic spot, that spot, due to a high energy which is basically given by the arc igniter, they will result into the movement of the cathodic spot somewhere around the surface of the cathode material. Student, please note that the movement of the cathode spot on the surface of the cathode material will cause the non-uniform evaporation or non-uniform erosion of the cathode material. So if you know that the energy of the cathode spot, energy of the plasma is maximum here, and this plasma spot or cathodic spot which is produced will have maximum energy at the center. However, when the spots move across, they will cause a non-uniform evaporation or non-uniform formation of plasma throughout the surface of the cathode material. So when, and secondly, this non-uniformity, apart from the non-uniformity of the evaporation of the surface of the cathode material, there is a possibility of the spot to get out from the surface of the cathode, and which will result into a non-uniform deposition of our thin film from the cathodic arc deposition process. So in order to get a uniform deposition of the thin film from cathodic arc deposition process, and in order to confine our cathode spot in cathodic arc deposition system on the cathode, we need a special type of arrangement. One type of arrangement is known as passive arrangement. So basically, in passive arrangement, a passive material like boron nitrides, the rings, they are used at the edges of the cathode. So their arrangement is very special in instrument. Okay, so what these boron nitride rings do, dear student, please note that boron nitride will confine the cathode spot onto the surface of the cathode. They will never allow the cathode spot to get out of the surface of the cathode. Another type of very special arrangement which is used to confine the cathode spot onto the surface of the cathode is known as magnetic confinement of the cathode spot. So magnetic field or magnetic coil in cathodic arc deposition system is used in a special way. So they basically, their magnetic field or magnetic pole or magnetic field of line will interact with the cathode spot and with the magnetic field of lines, because since you know that the cathode spot, which is basically a plasma, it has a mixture of protons, it has a mixture of ions, electrons and neutrals. So the magnetic field of line will interact electromagnetically with the electron, protons and neutrals and ions. So due to electromagnetic component or due to electromagnetic field in a specific direction, they will basically confine the plasma up to a specific region onto the surface of the substrate or onto the surface of the cathode in cathodic arc deposition system. So dear student, passive confinement and as well as magnetic confinement is used in cathodic arc deposition system in order to confine the cathode spot onto the surface of the cathode. So let's conclude the plasma arc igniter system. Okay, basically plasma arc igniter system consists of cathode and as well as electrode, as well as anode. The anode nozzle of the plasma arc igniter acts as a anode. The cathode and anode of the plasma arc igniter are connected with highly potential direct current source. Okay, the cooling system, usually a water cooling lines are incorporated across the plasma arc igniter system to decrease the temperature of the electrodes. Okay, or they are also used to decrease the temperature of the cathodic systems. The gases are fed in between the cathode and anode of the plasma arc igniter from the outside. So when the high potential is applied between the cathode and anode, they will result into a very high temperature spot at tip of the cathode. So when the gases are incorporated between the cathode and anode of the plasma arc igniter, the high temperature of the arc will result into a ionization of the introduced gas, and the introduced gas will be converted into a plasma. This plasma in plasma arc igniting system is directed from a small orifice onto the surface of the workpiece. Okay, so in this way basically the stream of the plasma having a very high energy and as well as temperature, that stream from the plasma arc igniter is used in cathodic arc deposition systems and as well as plasma arc welding. So now Dear student, what do you think? What is a cathode spot? Basically, the student, the cathodic arc deposition process takes place between two metallic electrodes in a vacuum. The range of vacuum is somewhere around 10 to the power minus 6 to 10 to the power minus 4 to 10 to the power minus 6 star. Okay. A cathodic arc is a low voltage, high current plasma discharge process. And as I have previously discussed, you can make the cathodic arc deposition process reactive by introducing a different types of reactive gases like nitrogen, argons, etc. Okay, so these reactive ion gases will interact with the material which is produced from the cathode, and then they will create a compound, and that compound is transported on the surface of the substrate, and that will result into a thin film. Okay, so in cathodic arc deposition, the arc current which is produced by a plasma arc is concentrated at the cathode at a discrete point, at a very specific point, at a very small point, which is known as a cathode spot. Okay, so this means that in cathodic arc deposition system, plasma arc igniter basically interact with a very small discrete point of the surface of the substrate, and when the highly energetic plasma arc interact with the discrete point, it will result into ionization of that small point, and this point is known as cathode spot on the cathode. Student, please note that the size of the cathode spot will vary. The size of the cathode spot is usually around 1 to 10 micrometer. The cathode spot has a very high current because, dear student, the energy of the plasma arc igniter stream is very high, so it will result into a very high current of the cathode spot. The current of the cathode spot is in the range of 1 to 10 ampere. Okay, a typically arc current is usually in the range of 100 ampere. So due to a very high temperature of the plasma arc, it will result into a creation of a higher current at the cathode spot, and this will basically cause a creation of a very dense plasma at the point of the cathode spot on the cathode. So, in a simple word, dear student, cathode spot is a point which is converted into a plasma by interacting a plasma arc igniter stream with a surface of a cathode. So the cathode spot is a point present on a surface of the substrate, and its range vary from 1 to 10 micrometer. So the diameter of the cathode spot is in the range of 1 to 10 micrometer, and the cathode spot has a very high current because of the very high energy of the plasma arc igniter. So this will result into a very dense plasma. So this will create a very dense plasma at a point of the cathode spot. So this dense plasma means that the cathodic or deposition system will create a very dense thin film on the surface of the substrate, because this dense plasma will be transported onto the surface of the substrate in the form of ions, and when they reach onto the surface of the substrate, the ions are basically get converted into a condensed thin film. So this is a plus point of the cathodic deposition process. Okay. So dear student, in a cathodic arc discharge process, the arc current is concentrated at the cathode at discrete site, and that site is known as cathode spot. The diameter of the cathode spot on the cathode surface in cathodic arc deposition process is in the range of 1 to 10 micrometer. The current carried by a cathode spot may reach from 1 to 10 ampere. And a typically odd discharge current is in the range of few hundred ampere, which will give rise to a dense plasma of the cathode material at cathode spot. The equipment extended from a few millimeter cathodes to a typically large plants of meter-size cathodes with a suitable power supplies. The extracted material from the cathode spot may be in the form of atom molecules or metallic droplets, which are transported onto the surface of the substrate and solidified and converted into a thin film. So, dear student, please note that in cathodic arc deposition process, the plasma arc igniter interact with a very small surface of the cathode, and that small region is get ionized, and that small region is known as cathode spot. The diameter of the ionized small region on the surface of the cathode is in the range of 1 to 10 micrometer, and the current of the cathode spot, or the current of the ionized small region on the surface of the cathode, is in the range of 1 to 10 ampere, and whereas the current of the plasma arc igniter is in the range of hundreds of amperes, and that current will result into ionization of a very dense plasma at the point of cathode, or this will result into a dense plasma at cathode spot. That dense plasma will be transported onto the surface of the substrate, will result into a thin film. Now, if I discuss cathodic arc deposition process, or if I discuss the cathodic spot on the basis of industrial processing, the industrialist basically deposits cathodic arc depositions thin films in over the larger area of the substrate in a small time. Basically, industrialists want to increase the work rate. So in this case, the deposition rate is increased, and deposition on the larger area of the substrate is done by introducing larger cathode or larger size cathode, which is in the range of meters, whereas in research scale usually the cathode used is in cathodic deposition process is in millimeters. So in industries they want to increase the efficiency of the cathode deposition system, so there they at advanced level they also use a multi plasma arc igniter to ignite or to evaporate or to create a cathode spot at multi points of the larger cathode. So when the multi-point or when the different points of the cathode material is converted into a cathode spot, this will result into a creation of a higher rate of the uh, plasma. And so this means that if you can basically deposit a cathode material in a shorter time on a same substrate over its larger area. So multi-igniter may be used in cathodic arc deposition process for creating multi-cathodic spots, and those multi-cathodic spots will create a huge range of plasma over the different point on the cathode material. So in this way a larger area of the substrate may be covered in industries in a shorter time. Furthermore, interesting fact to notice here is that you can also use multi substrate in a same cathodic arc reaction chamber. So basically the position of a substrate is adjusted in such a way that the substrate is in a certain angle to the cathodes, different cathode spots. So when the multi-arc igniter evaporate the cathode material in the cathode spot, that cathode material may easily be transported onto a multi-substrates. So in complex point of views, in industrial level, the industrialist may use single substrate and deposit the cathode material in a shorter time by using multi-arc igniter, and in this, and apart from this, the industrialists in some cases also use multi-substrates and multi-igniter on a same larger cathode. So this will result a deposition of the multi-substrate in a same time in a shorter amount of time. However, in local layers usually the researchers use a single cathode system, and that single cathode is just get evaporated at cathode spot and thin film is deposited from the single material. Or they may use a reactive gas in order to produce a compound inside the on the surface of the reaction chamber as on the surface of the substrate as a thin film. So dear student, it's depend on the requirement. In commercial scale we need a huge amount of the deposited thin films, so for that multi kind of plasma arc igniters and as well as multi substrates are used. However, in local scale, in a small lab, usually a single substrate and as well as single arc igniter are used to deposit a single phase or maybe a compound material on to the surface of the substrate as a thin film. So another important aspect to notice here is that, student, the current density of the cathode spot is very high. It is in the range of 10 raised to power 6 ampere per centimeter square. This means that the cathode spot has a very dense plasma. Okay, this higher current density is created because of the very high temperature of the plasma arc igniter. Okay, so due to a very high temperature and high kinetic energy of the stream of the plasma from the plasma arc igniter will result into creation of the cathode spot having a very high current density, which is in the range of 10 raised to power 6 ampere per meter square. Another important aspect about the cathode spot is that the local temperature of the cathode spot is around 15,000 Kelvin. Please note that it's not limited up to 15,000 Kelvin. Usually the cathode spot temperature may vary in the range of 10,000 Kelvin to even 30,000 Kelvin. So distant, what do you think why the range of temperature of cathode spot and as well as current density vary in cathodic arc deposition? So please note that temperature which is concentrated at cathode spot depend on the temperature given by a stream of the plasma from the plasma arc igniter, and the stream or the which has a temperature which is created by a plasma arc igniter will depend on the difference between the potential used inside the plasma arc igniter system and as well as the gas which is ionized inside the plasma arc igniter system. So the temperature of the cathode spot is not limited up to 15,000 degree Kelvin. This is just an average temperature. It may vary from 10,000 Kelvin to 30,000 Kelvin. Okay, so when the temperature of the cathode spot is like this is too much, this will result into an evaporation of the material at the cathode spot, and this will also cause an emission of the electron and as well as ionization. So this means that the cathode spot will be a combination of evaporated material in the form of electron and as well as ions. Okay, and it may have an excited atoms or neutral atom. So since the plasma density at the cathode spot is too much, current density of the cathode spot is too much, and secondly the temperature of the cathode spot is too much, this will result into a movement of the cathode spot, and the cathode spot will appear at one point, then it will disappear and then appear onto the other point of the surface of the cathode spot. Because in a simple word, let's explain the movement of the cathode spot on the surface of the cathode. As you know that the stream of the plasma which is introduced by plasma arc igniter have a very high kinetic energy. So when the high kinetic energy stream of the plasma arc igniter interact with the surface of the substrate, they will create cathode spot. So the energy, the kinetic energy from the arc igniter will be transported onto the cathode spot. This kinetic energy will ionize the small region of the cathode spot, and it will be basically transferred from arc igniter to the cathode spot, and this will cause the motion of the cathode spot because of the transformation of higher energy from the arc igniter. So in this way, the cathode spot will appear at different point of the cathode. So technically speaking, there are different types of techniques used in cathodic arc deposition to control the cathode spot. So I will discuss the way in which different scientists or in which the industrialists control the movement of the cathode spot on the surface of the substrate in later part of this lecture. So dear student, the type of the cathode spot basically depend on the movement of the cathode spot onto the surface of the substrate, onto the surface of the cathode. So there are two types of cathode spot. One type of cathode spot is known as fast moving cathode spot. Second type of cathode spot is known as slow moving cathode spot. So dear student, the movement or the velocity of cathode spot on the surface of the cathode in cathodic arc deposition process depends on different type of factors. So different types of factors basically influence the velocity, or they influence the movement of the cathode spot on the surface of the substrate. First factor which influence the movement of the cathode spot on the surface of cathode is the composition of cathode. So dear student, in case if let make this explanation very clear. In a case if you are using single uniform cathode material, then the cathode spot will travel with a uniform velocity over the surface of the cathode. But please note that this is ideal condition. Usually the cathode material is based on not 100% pure and uniform material. There may be a different kind of defects, and there may be a variation of the surface of the cathode material. So this will result into a variation of the velocity of the cathode spot at a different point of the cathode. So in order, if you want to have a cathode spot having a uniform velocity over the surface of the cathode, you need to have a material having a very good uniformity, and this roughness is, and have a very less roughness, and it has more smoothness. So the composition of the cathode play important role in cathode velocity. Let's say in a case if you are using a alloy of different metallic material, and then in that case the alloys has a variable composition. Like if you are using aluminium chromium alloy or aluminium nickel alloy, both the aluminium and nickel have a different melting point. So they have a different structure. Due to the different in melting point and different in structure, they will result into a variation of the velocity of the cathode spot over a different position. Similarly, if you are using compound, okay, then in that case, if the compound material of the cathode is uniform, then you will get a cathode spot velocity in a uniform fashion. However, if the surface of those compounds are rough or they vary, then they will result into a difference in a velocity of the cathode spot over the surface of the cathode material. The velocity of the cathode spot also depend on the pressure of gas inside the reaction chamber. Dear student, please note that it is very important factor of vacuum science. Vacuum technology is based on gas pressure which is used inside the reaction chamber. If the gas used inside the reaction chamber has very low vapor pressure, or it has a very low vacuum pressure in the range of torrs like 10 raised to power minus 4 torrs to 10 raised to power minus 6 or 10 raised to minus 8 or 10 raised to minus 10 or 10 raised to power minus 12 torr, then in that case the mean free path increase. So this means that the ion which are produced at the cathode spot, they will never interact with each other, they will never collide with each other because the mean free path for them become increase. So in this way the cathode spot velocity will increase. However, in a case if the vacuum pressure, let's say suppose it is a room vacuum pressure, then in room pressure, then in that case the cathode spot, which is basically a combination of an ion, electron, neutrals or excited atom, they will interact with each other, they will collide with each other. Then due to this, the movement or the velocity of the cathode spot will change. So the velocity of the cathode spot depend on the pressure which is used inside the cathodic Hawk deposition system. Another interesting factor which influence the velocity of the cathode spot is the application of magnetic field. So this is also very important factor to be considered. Just please note that, as I have discussed, the cathode spot is basically a plasma, okay, and plasma is combination of neutrals, excited atoms, molecules, ions and electrons, etc. So the magnetic field has a magnetic field of line, and these magnetic field of line interact with ion, neutrals and electron in a different way. Basically, electrons and ions, on the application of magnetic field, they are deflected by a certain pole. They are deflected toward a certain pole. Whereas neutrals, basically, they travel without interacting themselves with field of line. So this means that magnetic fields used in a cathodic Hawk deposition system control the movement of the ions and electrons inside the cathode spot. So by using the magnetic field, the velocity of the cathode spot is controlled, it is confined. Now, dear student, what do you think? how the cathode spot is specified. What are the specification of the cathode spot? What are the specs of cathode spot? Different cathode spot is specified on the basis of the spot size or on the basis of spot diameter. Please note that usually the diameter of cathode spot varies from 1 to 10 micrometer. Okay, the cathode spot may be specified on the basis of spot velocity. There are two types of cathode spot. One type of cathode spot is known as slow moving cathode spot, and the second type of cathode spot is known as fast moving cathode spot. So the cathode spot may be specified on the basis of the velocity of the cathode spot. Cathode spot is also specified on the basis of current density which is present inside the cathode spot. Current density is based on the excited atoms, molecules, ions and electron present inside the cathode spot. So the current density in the cathode spot vary. It will depend on the nature of the cathode material and also on the plasma arc igniter. If the plasma arc igniter has a higher current, then the current density of the cathode spot will be more. Okay, and similarly the material of the cathode, if it is dense, then there will be a dense current density. Secondly, if the melting temperature of material is less, then it will further create a higher current density. Okay, so the cathode spot may be or specified on the basis of the current density present inside the cathode spot. Cathode spot is also specified on the basis of erosion rate. Erosion is basically a removal of the cathode material from the cathode spot. Okay, so there may be a higher rate of erosion or higher rate of removal of the material from cathode spot, and there may be a slow rate of removal of the material from cathode spot. So the cathode spot may be specified on the basis of removal of the cathode material from the surface of cathode. Dear student, please note that the erosion of the material from the cathode spot depend on the nature of the cathode material. This may include the melting point of cathode material, structure of the cathode material, the uniformity or non-uniformity of the cathode material. It will also depend on the temperature or kinetic energy of the plasma arc, which is produced by plasma arc igniter at the surface of cathode spot. So the erosion rate depend on electrode and as well as cathode as well as plasma arc igniter. So the cathode spot is also specified on the basis of the erosion rate of cathode material at the cathode spot. Cathode spot is also specified on the basis of average current density. As I have discussed, the current density may vary from 10 raised to power 4 ampere per meter square to 10 raised to power 8 ampere per meter square. So it's vary. So the spot is specified on the basis of the average current which is produced from the cathode spot. And dear student, please note that again the average current of cathode spot will depend on the nature of the cathode material, number one, and secondly it will depend on the nature of the plasma or igniter. Another interesting fact here to consider is the pressure inside the cathodic arc chamber. So the average current will also depend on the pressure inside the arc igniter system. Okay, so if the pressure is a low vacuum pressure, then there will be a less collision of the excited atoms, ions or electron inside the cathode spot, and this will result into a higher average current per spot. Okay, so these are the three factors on which the average current depends, and on the basis of the average current the cathode spot is specified in cathodic arc deposition systems. Yes, student, a cathodic arc deposition system is basically based on two types. One type of cathodic arc deposition system is known as conventional cathodic arc deposition system, which is based on one cathode, one anode, and one substrate. Whereas the second type of the cathodic arc deposition system is known as dual cathodic arc deposition system. Dual cathodic arc deposition system is common in industrial setup because dual cathodic arc deposition systems use multi electrode material and multi cathode and as well as multi anode. Okay, this means, dear student, however, most commonly the dual cathodic arc deposition systems used in industries are based on two cathodes and as well as two anodes. Okay, the internal setup of dual cathodic arc deposition system may be represented by schematically as. Consider this is a reaction chamber of dual cathodic arc deposition system. The reaction chamber of dual cathodic arc deposition system consists of two electrodes, and these consist of two cathodes. So these blue one, these two represent the cathode in the reaction chamber of dual cathodic arc deposition system. And similarly, dual cathodic arc system consists of anodes, multi-anodes. Please note that both the cathode and anode are connected with each other with the help of an insulator which is present between the cathodes and anode material. The cathode and anode are made cathode and anode by connecting them with high potential source. The cathode is connected with negative terminal of the direct current potential source. So this is a negative terminal of the direct current potential source. Dear student, please note that This is just for your information that the dual cathodic arc systems or even conventional cathodic arc systems are connected with a direct current potential source, because direct current potential source are uh, efficient and they basically give a uniform current and potential to the electrodes. So the negative terminal of the direct current potential source is connected with cathode, whereas the anode is connected with a positive terminal of the potential source. The student, please note that the dual cathode arc deposition system consists of a substrate holder. So this is interesting. In some dual cathodic arc system, the substrate holder is fixed. However, in some cases, the substrate holder is rotated. So now what is the advantage and what is the disadvantage of fixed and movable substrate holder? If the substrate holder is rotating, this will result into a uniform deposition of thin film produced by dual arc deposition. However, in case if the substrate holder is not rotating, this will result into a non-uniform deposition of the thin film. I will discuss this in later part, that how we get non-uniform deposition without rotating the substrate holder and how we can get a uniform deposition by rotating the substrate holder. So dear student, please note that since we need to deposit a ion onto the surface of the substrate holder, so we need to onto the surface of substrate, we need to connect this substrate holder with a negative potential. When this substrate holder is connected with negative potential, then this ion from the cathode spots will be easily deposited onto the surface of the substrate. So this is a representation of a substrate which is present onto the surface of the substrate holder. The substrate holder is connected with a negative terminal of the potential source, and it is the substrate holder act as a cathode in the dual cathodic arc deposition systems. So now, in order to do deposition, dear student, please note that we need to create a vacuum inside the cathodic arc deposition reaction chamber. So different types of pumps, vacuum pumps, are connected with the vacuum chamber. So the vacuum pump used in dual cathodic arc deposition system may be a single one, or it may be a complex one, like it may be a combination of different types of vacuum pumps. Dear student, please note that usually the vapor pressure, the vacuum pressure in the reaction chamber in dual cathodic arc deposition is in the range of 10 raised to power minus 4 to 10 raised to power minus 6 stars. But if you want to prepare highly pure thin films, in that case extremely low vacuum pressure is used. It could be in the range of 10 raised to power minus 8 to 10 raised to power minus 10, or even 10 raised to power minus 12 torr. So in order to achieve such low vacuum pressure, the cathodic arc deposition technique use a combination of different types of pumps. These pumps may be mechanical pump they may be combination of mechanical, rotary, turbomolecular or diffusion pump. However, please note that diffusion pump is rare commonly used in cathodic arc deposition process. The reason of rare use of diffusion pump is that this pump basically use the different types of oils, and the oil vapor may be introduced inside the vacuum chamber and inside the reaction chamber of the cathodic arc deposition system, and uh, they may cause impurity in the thin film. So due to this, diffusion pump is rare commonly used in dual cathodic arc system. However, turbomolecular pump, rotary pump are used to create a vacuum inside the reaction chamber. Okay. This will please note that especially if you want to produce a highly pure thin film, especially in microelectronic industry, the purity is achieved at a very low vacuum pressure, because at very low vacuum pressure the collision of the vapor phase of the plasma, which include ion, electrons or neutrons, that become less, and due to this the purity will be very good in thin films. Okay, so now in order to prepare a thin film from dual cathodic arc deposition process, the cathode, in order to prepare, dear student, a complex compounds like if you want to prepare a titanium nitride, so you need to incorporate a reactive gas. Okay, so this is basically a representation of incorporation of a reactive gas. Let's say you are going to prepare titanium nitride, so electrode usually is made of titanium. Okay, and whereas the nitrogen gas is introduced inside the reaction chamber. So the plasma which is generated from the titanium is interacted with the nitrogen, and in this way they form a titanium nitride, which is incorporated onto the surface of the substrate as a in a gaseous form, and which at the end of the day is converted into a condensed phase and then into a thin film. So in order to prepare a compound, different types of compound, the dual cathodic arc deposition system have a setup for incorporation of reactive gases in it. Okay. Now let's discuss about how we basically deposit a cathode material onto the surface of the substrate. Please note that in dual cathodic arc deposition process, plasma arc igniter is introduced on the surface of the cathode material. So this plasma arc igniter has a stream of plasma, and this stream of the plasma has a temperature in thousands of degrees centigrade. So when this stream interacts with the surface of the substrate, this will result, and with the surface of the cathode, this will result into a production of cathode spot. Cathode spot is a combination of ion, electron, neutral and excited atoms. So these ionized gas at the cathode spot, or this plasma which is created at the cathode spot, will have a combination of the ionized gas atoms. Okay, the electron will be deflected toward the anode, okay, like this, and they will be, and also toward this, whereas the ions which are positively charged will move toward the surface of the substrate. The substrate is connected with a negative potential, so substrate act as a cathode. So due to this, the ion from the cathode material, from the cathode spot, will travel onto the surface of the substrate, which has a negative potential, and in this way they will be deposited onto the surface of substrate. Now, interesting point to notice here is that dual cathodic or deposition system deposit complex type of thin films. So basically you can prepare complex type of thin films and even compound on the surface of the substrate, and even you can deposit a same type of material, of cathode material, onto the surface of the substrate. So it's depend on the requirement. Let's say if the cathode material is made of same material, suppose cathode material is made of copper and copper, okay, so this in dual setup, the both the cathode, this one and this one, will have a separate arc igniter, somewhere igniter here and somewhere igniter here, okay. So when the igniters, this igniter interacts with the cathode material of copper, and similarly igniter, it's not represented but schematically, but if igniter will be somewhere here, when it will be interacted with the surface of this cathode material, they will both, this cathode material of copper and this cathode material both will basically evaporate, what will create cathode spot on the cathode material, and then they will evaporate the cathode copper material onto the surface of the substrate, like this, and in this way basically we will deposit a same material in a very shorter time. Similarly, we can produce in dual cathodic or deposition system, we can produce complex materials, material with a complex chemical compositions, like let's say this material is made of, cathode material is made of copper, and this material is made of aluminium. So we can basically both deposit copper and aluminium onto the surface of the substrate. And similarly, if the both material, like this material is, let's suppose it is made of aluminium and this material is made of copper, and if we incorporate different types of reactive gases like nitrogen, or argon, or any kind of different types of gas, then we can basically prepare different types of chemical compositions, because material like the cathode material like the aluminium will also interact with reactive gas like nitrogen, and similarly the copper cathode material which is made of copper will also interact with nitrogen material. So in this way we will deposit a different kind of complex composition onto the surface of the substrate. Student, please note that in industrial case we basically use a complex types of cathodic or deposition systems, okay. However, in lab, conventional types of cathodic or deposition systems is more common, okay. So the important factor to notice, it is very important for, especially for researcher, okay, it is good to use a rotating systems, okay, rotating sample holder. When the sample holder rotate, okay, then the sample, the substrate material will deposit a thin film uniformly, because at every point the cathodic material from the cathode spot will be deposited onto the surface of the substrate. However, in case if the substrate holder is static, then the cathodic material which is will deposit onto the surface of the substrate will vary, and this will cause a non-uniformity onto the surface of the substrate. This important point in cathodic arc deposition process is that the potential the the temperature of the arc igniter is too much. So when arc igniter interact with the surface excuse me, with the surface of the substrate, with the surface of the cathode, the temperature, since the temperature of arc igniter is too much, when interact with the surface of the substrate, with the surface of the cathode, it will abruptly evaporate the cathode material from the cathode spot. So due to abrupt evaporation, this will cause a deposition of a kind of nanoparticles onto the surface of the substrate material, and as well as it will also cause porosity onto the surface of the substrate material. So this is a drawback of cathodic arc deposition. You can slightly avoid the deposition of nanoparticle and also porosity slightly, but it's not controllable by rotating the substrate. Okay, so this is the key drawback which limit the potential of the cathodic arc deposition process into a microelectronic industry, because we in microelectronics industry we need highly purity, though the distribution of uniformity may be done by using different types of adjustment inside the reaction chamber, but still it is very difficult to control the uniformity over the whole substrate by using dual cathodic arc deposition systems. So dear student, in industries, please note that advanced type of dual cathodic arc deposition system are used. What do you think? What is could be a difference between the advanced dual cathodic arc deposition system and as well as dual cathodic arc deposition systems? Dear student, please note that generally in conventional dual cathodic arc deposition system, dual cathodic arc deposition consists of a reaction chamber. Inside the reaction chamber, it has cathodes. Okay, usually it has two cathodes, and similarly it has dual cathodic arc system has also anode. Okay, the cathodes are connected with a negative terminal of the potential source, and whereas the anodes are connected with the positive terminal of the potential source. Okay, and there is also a substrate. Usually there are also present a substrate holder. Substrate holder may be rotatic or may be static. On the substrate holder, the substrate is placed. Okay, and the substrate holder is connected with a negative terminal of the potential source. So substrate holder also act as a cathode inside the dual cathodic arc deposition system. So now, how the advanced dual cathodic arc deposition systems are made? Visually, the student, as you know that cathode spot is created onto the surface of the substrate. So advanced cathodic arc systems use magnetic field near the uh, cathode. So this magnetic field basically confined the cathode spot onto the surface of the substrate. This means that the cathode spot will move uniformly over the surface of the substrate, which will result on the surface of the cathode, which will result into a uniform erosion of the surface of the substrate, or which will result into a uniform removal of the cathode material in cathode spot. Okay, so the magnetic field basically confined the cathode spot movement and cathode spot velocity onto the surface of the cathode. What do you think? How magnetic field confine the movement or velocity of cathode spot. The movement or velocity of the cathode spot, which is a combination of plasma, is controlled by the magnetic field of line. So the magnetic field of line interact with the charged particle of the plasma, and as a result the cathodic spot is confined. Okay, so this advanced setup of incorporating of magnetic field will result into the avoidance of non-uniform erosion by the cathode spot over the surface of the cathode. So in this way, at the end of the day, you will get possibly uniform thin film. Advanced cathodic arc system also consists of a cooling setup. Just please note that plasma arc, which basically create a cathode spot on the surface of the cathode, have a very high temperature. It is in thousands of degrees centigrade. So in order to cool the substrate material, we need a cooling cathode material, we need a cooling system. Okay, this cooling system basically is very helpful, because if there is no cooling system, the high temperature which is created by the plasma arc igniter will damage the surface of the cathode material. So at the end of the day, we basically get a defect based thin films. So in order to avoid the defects, and the cooling setup is basically introduced across the cathode. As it is same just like a conventional dual cathodic arc deposition system. The advanced cathodic arc deposition systems have also a vacuum chamber, have also a vacuum pump, and usually in advanced cathodic arc deposition system, the vacuum pump are used to create a very low vacuum in the range of 10 to the power minus 6 to 10 to the power minus 8, and even up to 10 to the power minus 10 torque, in order in case if you want to prepare highly pure thin films. So just like a conventional cathodic arc deposition system, the advanced cathodic arc deposition systems have a plasma arc igniter which produce a cathode spot on the surface of the cathode. Similarly, the reaction gases, there is a cathodic arc deposition system have a setup for introduction of the reactive gases inside the reaction chamber if you want to prepare a complex material. Now, this is interesting factor. This is interesting fact. Advanced cathodic arc deposition systems use magnets even inside the reaction chamber. First, these magnetic representation near the cathode are basically used to control the cathode spot onto the surface of the cathode material. However, the magnetic field which is used across the reaction chamber of advanced dual cathodic arc system are basically used to control the deflection and direction of the ions, electrons and neutral inside the reaction chamber, and they direct their motion on, especially the motion or the movement of the ion onto the surface of the substrate material. So this is the key difference between the advanced and conventional dual cathodic arc deposition system. Conventional dual cathodic arc deposition system just use simple electrodes which are cathodes and on anode, and they are basically the spot is created onto the cathode, and the cathode the material from the cathode spot is transported onto the surface of substrate. However, in advanced dual cathodic arc deposition systems, the cathode spot is confined by a magnetic field, so they use magnetic field near the cathode to control the cathode spot. The temperature of the cathode spot and even the cathode is decreased by using cooling setup. And apart from this, special arrangement of magnetic field or magnet is introduced inside the reaction chamber to control the deflection of electron and even to control the deflection and movement of the ion onto the surface of the substrate. So the advanced system basically used some additional magnetic field setup and as well as cooling setup. So due to these application of the magnetic field inside the reaction chamber, basically they will result into a uniformity of distribution of ions onto the surface of the substrate. And at the end of the day, by using this advanced setup, basically we can produce highly uniform thin films. Now, dear student, what do you think? What are the types of cathodic arc deposition technique? What are the types of cathodic arc deposition systems? Basically, the cathodic arc deposition technique is divided into two types. One type of cathodic arc deposition process is known as pulse cathodic arc deposition. Second type of cathodic arc deposition is known as continuous cathodic arc deposition. So now, what do you think, student? What is pulsed cathodic arc deposition process? In cathodic pulse or discharge, the plasma arc igniter generate a plasma in pulse fashion, form the cathode spot on the electrode. The pulse cathodic arc plasma have a current around 5000 ampere. Pulse length is up to from few millisecond to few nanosecond and relatively high repetition rate. Okay, a major advantage of pulse operation is the relatively low average power, which reduce the cooling requirement. No electrode cooling is required if the source is operated at low duty factor. This means that in this type of deposition, we have time interval for cooling electrode and a substrate, but throughput will be less. Okay, so dear student, in simple word, the pulsed cathodic arc deposition process use plasma arc igniter in pulsed fashion. So basically, plasma arc igniter operate its pulse in few millisecond to few nanosecond. So for some millisecond or for some nanosecond, the plasma arc igniter will switch on and it will interact with cathode material and then it will shut down, and then again it will switch on and after a few millisecond and nanosecond it will shut down. So in this way, in a pulse fashion, the cathodic spot will be created onto the surface of cathode. Okay, but the good point of cathodic pulse fashion cathodic arc deposition is that we don't need any kind of cooling setup for this process. So this will basically avoid the additional potential requirements which are, or additional power requirements which are usually used in conventional continuous cathodic arc deposition process. Okay, however, the drawback of this process is that the throughput is usually less in cathodic, in pulse cathodic or deposition process. This means that less material or thinner film will be deposited by using pulse cathodic or deposition process as compared to continuous or deposition process. However, this technique gives us a good opportunity of depositing defect-free uniform thin films. So now let's explain pulsed cathodic or deposition process with a schematic diagram. This is just a conventional representation of uh, dual cathodic or deposition systems. So dear student, as I have previously discussed that now in what will be the difference in pulse and conventional continuous dual cathodic or deposition system. Basically here this schematic represent the plasma arc igniter. So in pulse cathodic arc deposition process, plasma arc igniter will interact with the small region of the cathode like this for few millisecond to few nanosecond, and then this plasma arc igniter will be pushed back and it will be shut down. Okay, and again after a few millisecond or a few nanosecond, the plasma arc igniter again will interact with the cathode spot, and then for a few millisecond or nanosecond, and then it will be shut down. So now interesting point to notice here is that this temperature due to a interaction of the arc igniter with cathode for a small amount of time, okay, the temperature of the cathode will not increase too much. So in this case we don't need any kind of cooling setup across the electrode of the across the cathode in the pulsed cathodic arc deposition system. So this basically decreases the power factor or decreases the additional power required to the cathodic arc deposition systems. Another good thing is that with the incorporation or with the interaction of plasma in a pulse fashion with a cathode will basically also control the thickness of the films. So you can basically adjust the interaction of igniter in with a number of pulses onto the surface of substrate, and by adjusting the number of pulses you can basically produce thick or thinner films. Let's say you are, if you want, let's say you want to prepare a film with a less thickness, or if you want to prepare ultra thin film, in that case you will use less pulse of plasma. Let's say 1 2 3 4 5 or like 10 pulses of plasma, and in this case basically lesser material will be eroded and evaporated and deposited onto the surface of the substrate. And in a case if you want to deposit a thicker film of the cathode material, in that case you need to increase the number of pulses, like 1000, 100 pulses, 500 pulses, 1000 pulses, and even more, and in this case you will get more material onto the surface of the substrate. So this is the pulse cathodic arc deposition process is very important for the researchers, especially those who are working in ultra thin films. Okay, as you know that the property of the material changes at very small scale. Richard Feynman said there is a plenty of room at bottom. So if you want to innovate material, you need to deposit ultra thin film onto the surface of the substrate. So in this case, if you control the number of pulses or if you decreases the number of pulses, you can basically get ultra thin film, even film in the range of 1 to 10 nanometer. And in this way basically you can innovate, as a researcher you can basically innovate novel properties of material, but is at very small local scale. Okay, and in case of bulk material or in case of thicker material, you can basically increase the number of pulses. Okay, however, please student note that the properties of bulk are different as compared to the properties of the ultra thin film. So it's depend on your requirement, that what kind of material you are going to produce. You can use the pulse cathodic or deposition process in that way. Now the second type of cathodic or deposition process is known as continuous cathodic or deposition process. So continuous cathodic or deposition process is just like a conventional cathodic or deposition process. The continuous cathodic or deposition discharge or continuous arc deposition process, the plasma arc igniter generate a plasma in a continuous fashion from the cathode spot in the electrode, which mean that the throughput productivity or thin film deposition will be more in shorter time, but the cathode spot don't cool over the period of time and may lead to non-uniform deposition and non-uniform erosion of the electrode material. Though cathodic arc deposition is very common technique used to deposit thin films, but the drawback with cathodic arc deposition process is that the cathode arc is continuously used to produce a cathode spot onto the surface of the thin films. So when the cathode spot, the plasma arc igniter continuously interact with cathode surface and cathode spot, this will result into increase in the temperature of cathode, and this increase of the temperature in a continuous fashion will cause a loss of power, mean an extra or additional power will be used, and secondly it will also cause a damage to the surface of the cathode. And due to high power of arc igniter in a creating a cathode spot in a continuous fashion, this will also possibly cause a damage or defected deposited thin films. Okay, the advantage of continuous process is that this process basically give us a continuous deposition of the thin films. However, the erosion or the removal of the material from the electrode surface will be non-uniform. Secondly, this continuous arc deposition, cathodic arc deposition system will have a continuous cooling system in order to decrease the additional heat given to the cathode material. Let's represent the cathodic or continuous cathodic arc deposition process schematic diagram. So this is just a conventional cathodic arc deposition system. Okay. Now, in this setup, the plasma arc igniter will continuously interact with the surface of the cathode material. Okay, and this interaction will cause thousands of degrees of temperature of the cathode material at the cathode spot. This means that the additional the temperature of the rest of the surface of the cathode will also increase. So in order to decrease this temperature, the continuous cathodic deposition system will use a water cooling system or different types of cooling gases. Okay, so now when this arc igniter continuously interact with the surface of the cathode, they will create a cathode spot with high temperature in a continuous fashion. Then this means that the high temperature may cause a defect onto the surface of the onto the surface of the cathode, and when the material is transported onto the surface of the substrate in a continuous fashion, there is a possibility of creation of impurities onto the surface of the substrate. And secondly, the continuous uh, deposition system gives continuous potential, continuous energy to the cathode spot. This means that the cathode material which is transported on the surface of the substrate will have very high energy, and they may also cause the damage to the surface of the substrate. So due to this, dear student, I usually prefer to use pulsed cathodic arc deposition system, because the pulse cathodic arc deposition gives you a diversity, especially in deposition. It will give you a continuous uniform deposition with a controlled thickness of the film. So you can basically prepare even ultra thin film with a unique properties with the pulse arc deposition process. But with the continuous arc deposition process, it is difficult to control the thickness of the film onto the surface of the substrate. So, student, what do you think? What will be the effect of a pressure in cathodic arc deposition process? Like, what is the role of pressure inside the reaction chamber in cathodic arc deposition process? Dear student, please note that increase in pressure will cause the gas scattering, because in higher pressure the distance between the substrate and the electrode, especially cathode, become more than the mean free path, which will result into a deflection of the plasma all over the reaction chamber, and even may be deposited onto the surface of the electrodes. So this means that with increase in pressure inside the vacuum chamber, the incoming flux of plasma will decrease on the surface of the substrate in the form of thin films. The vacuum pressure in the reaction chamber in any type of any type of vacuum based system is very important. If you have a higher pressure inside the reaction chamber, then the gases, ionized gases, which are specially produced in cathodic arc deposition process, will interact with each other. They will ionized ion and electrons, they will collide with each other. This means that the mean free path will be less than the mean free path between the electrode and the substrate material. So due to collision of ions, electrons and neutrals and atoms, they will result into damage of the desired deposited thin film, and also less amount of the material from the cathode will reach onto the surface of the substrate, and at the end of the day we will get thinner thin film with non-uniform deposition. However, if the pressure is less, like suppose the vacuum pressure is in the range of 10 raised to power minus 4 and above, like 10 raised to power minus 6 or 10 raised to power minus 8, at such low pressure the mean free path for ions, electrons, neutrals and excited atom which are present in cathode spot will increase, and due to increase in mean free path, the ions from the cathode will reach to the surface of the substrate without any kind of collision or interaction. So at the end of the day, we will get a uniform thin film at very low pressure. Student, what do you think? What is a mean free path? Basically, the student, mean free path is an average distance over which a moving particle substantially changes its direction or energy, typically as a result of one or more successive collisions with other particles. So what this means? Mean free path is the average distance between the two or more molecules collision. So the distance before the two molecules collide with each other, so its average distance is a mean free path. The student, please note that mean free path is very important to be considered in vacuum based processes. If the vacuum pressure is high, this means that the mean free path between the ionized, in case of cathodic or deposition, the mean free path between the ions, neutrals, electrons and excited atom will be less. So when the mean free path between the plasma, ions, electrons, neutrals and excited atom become less, then they will collide with each other inside the reaction chamber. So when they collide with each other and even with the walls of reaction chamber, then they will result into defects and also impurities in the thin films. So due to lesser mean free path, we will get thinner film with high density of impurities and defects. However, in cathodic or deposition system, dear student, please note that vacuum pumps are used. These vacuum pumps usually operate around 10 raised to power minus 4 to 10 raised to power minus 10 and even up to 10 raised to power minus 12 torque. So this is extremely low vacuum pressure. So due to very low vacuum pressure, the mean free path between the ions, electrons, neutrals and excited atom which are present in cathode spot on cathode surface will increase, and their mean free path will be even more than the distance between the electrodes and substrate. So due to increase in a distance or increase in a mean free path between the electrons neutrons, electron, ions, neutrals, and excited atom, they will result into lesser collision with each other and even lesser collision with the wall of the reaction chamber. And so due to this, at the end of the day, we get uniform deposition onto the surface of the substrate. So the mean free path, if the mean free path is less, we will get thinner film with full of impurities and defects. However, if the mean free path is more, then at the end of the day we will get thicker film with less defects and impurities. What are the factor influencing the arc voltage in cathodic arc deposition process? Dear student, please note that in plasma arc discharge process, the arc voltage is less and the arc current is too high. Okay, so the arc voltage used in plasma cathodic arc discharge process is less. However, the arc current used is very high. The arc voltage is affected by composition of target. Usually it's depend on the composition of the cathode material, and in some cases it's also depend on the substrate material. Secondly, arc voltage also depend on the processing temperature, so it will vary with the processing temperature. Okay, now what do you think, what are the factors affecting the arc current density? Arc current density is affected by the composition of target and sometimes substrate. Basically, the composition of material will decide the density of the arc current. It also depends on the arc spot velocity. Okay, arc current density depend on the arc spot velocity. Arc current density also depend on the arc spot size. If the arc spot velocity is more, this means that arc current density is less. In a case if arc spot size is more, it means that arc has a higher current density. Higher area of the cathode material is interacting with arc igniter. Now, student, one of the interesting observation in cathodic arc deposition process is that in some cathodic arc deposition process there occur a splitting of cathodic spot. It is commonly observed that when arc igniter interact with the surface of cathode in many cathodic arc deposition systems, the cathode igniter cause a cathode spot, and that this cathode spot usually divide into two and even more cathode spot on the surface of the cathode. In cathodic arc deposition process, the cathode spots start with one. Okay, initially the arc igniter produce a one cathode spot at a point at which it is interacted, and then that cathode spot may be splitted into two or more spots. The increase in number of spots is usually caused by arc current, and this is called splitting of cathode spots. So this is very important factor to notice. Basically, when the arc and igniter interact with the surface of the cathode material, they create a cathode spot. The cathode spot has a very high current and even very high temperature, which is further distributed or which is further transferred onto the surface of the cathode material. So basically the stress is created over the whole surface of cathode material due to a variation of a temperature at a different part of the cathode material. So when the temperature and the current varied at a different spot, a different point of the cathode material, if the melting point of cathode material is less, then the current and the energy transferred at a different point of the cathode material, then they will result into many spots or many cathodic spots on the surface of single cathode. And these many cathode spots will also be a combination of plasmas. They will be a combination of neutrals, excited atoms, ions, and electrons. So, dear student, the splitting of cathodic arc into 1, 2, and even more cathodic spot is common in cathodic arc deposition process. And when they are splitted, interesting point to notice here is that if you want to prepare highly pure thin films, when you get cathode spots splitted over the whole surface, then all those cathode spots have a different erosion rates. Okay, basically the material from those cathode spots will be removed in a different rate. So due to this, they will cause a non-uniformity of the deposited thin film on the surface of the substrate. So if you are doing very specified research, then you need to avoid the cathodic splitting on the cathode surface, and you need to do it in a precise fashion. So due to this, I will prefer to use pulsed cathodic arc deposition systems, because you have to use the pulse for a specific time, and this will decrease the amount of creation, or this will decrease the possibility of creation of many cathodic spot on the surface of cathode. So, student, what do you think? What is the relation of cathodic arc spot velocity with cathode current? The student, please note that both the cathode arc velocity and the cathode current are relevant. The student, as you know that the plasma arc igniter gives a current to the surface of the cathode material, or it also give a very high, which will cause a very high temperature of the surface of the substrate, and this will result into a creation of the plasma arc spot, okay, or cathodic arc spot. So if the current of the cathode current increases, this will basically cause the increase in the increase in the density of the cathode spot, and as a result the arc spot velocity will decrease. Dear student, what do you think that why the velocity is decreases with increase in the cathode current? The basic reason is quite simple. Cathode current give a very high temperature to the surface of the cathode, and this will increase the density of the current, and this will increase the density of the plasma. So when the plasma become dense, this will basically decrease the movement or decrease the velocity of the arc spot. What do you think? What is cathode current? Electrons have a negative charge and are attracted to the positive toward the positive charge. Electron flows through a conductive material from negative to positive side. Therefore, electron tends to flow out of the cathode, which is a negative terminal, and into an anode or toward anode, which is a positive terminal. Such flow of electrons generate a current, and this current is known as cathodic current. So in a simple word, dear student, cathodic current is basically a flow of a current from a cathode toward the anode. Usually cathode is connected with the negative terminal of the potential source, and whereas anode is connected to a positive terminal of potential source. So when both of them are connected to positive and negative terminal of potential source, the electron from the negative terminal of potential source will travel toward positive terminal of the potential source. So if we increase the current, the cathode arc velocity will fall. This is because that with increase in current, the erosion yield or the removal yield of the cathode material will increase. And when the removal yield increase, because this means that the density of the plasma become too much. So when the density become too much, this will result into decrease in arc velocity with a cathode temperature or with a cathode current. So dear student, in a conclusion, please note that the cathode arc velocity depend on cathode current and cathode temperature. If the cathode temperature is more than, or if the cathode current is more, then the arc cathodic arc velocity will decrease, because the arc velocity will be result of the plasma created by the plasma spot, and due to high temperature and high current, the density of the plasma spot increases, which will result into decrease in velocity of the cathodic arc spot. One of the very important aspect which need to be considered in cathodic arc deposition process is the confinement of cathode spot in cathodic arc deposition process. This isn't basically, as I have discussed too much about this, that cathode spot travel throughout the surface of the cathode material. So now the plasma arc igniter give the cathode spot too much temperature, current, and as well as kinetic energy. So that is basically transferred from the plasma arc igniter into the cathode spot. So due to this, the transformation of energy, the cathode spot start moving, and the velocity of cathode spot just increases with the increase in the transfer of kinetic energy, current, and temperature. The velocity of cathode spot usually is found in the range of 20 to 100 meter per second. Now, in such high velocity, there is a possibility of flying off the cathode spot from the cathode surface, and secondly, due to its higher velocity throughout the surface of the cathode, there is basically this will cause a non-uniform erosion or non-uniform removal of material throughout the cathode surface, so which will result into a non-uniform deposition. There are also different reasons for non-uniformity. First is basically a movement of cathode spot throughout the surface. Secondly, just please note that every cathode material has different type of roughness and different types of surface physical and chemical morphology. So now when the cathode spot move due to a difference in the surface properties and due to a difference in physical and chemical properties of surface of cathode material, this will cause a difference in erosion and which will result in difference in deposited spot. So due to this, the spot confinement is a very important step in cathodic ore deposition process. In cathodic arc deposition process, the cathode arc spot travel throughout the surface of cathode. If there is no confinement set up in cathode arc deposition systems, then it will result in non-uniform erosion on the surface of cathode material, and which as a result will end up with non-uniform deposition of the thin film on the substrate. So there are basically different kind of method introduced to control and confine the cathode spot or cathode or on the surface of cathode. Okay, so this due to the higher velocity non-uniform deposition and control of the cathode spot over the surface of the cathode material lead to different types of methods of confinement of cathode spot onto the surface of the cathode material. Dear student, please note that the cathodic spot confinement is very important step in cathodic or deposition process, since you know that when plasma or igniter interact with the surface of cathode material get small part of the cathode material is converted into a plasma, and that part or that small area which is in the range of 1 to 10 micrometer is known as cathode spot. Since the plasma arc igniter give very high amount of current and temperature, this causes the high velocity of cathode spot. So the cathode spots start to travel over the surface of cathode material. The velocity of cathode is in the range of 20 to 100 meter per second and even more. It's depend on the energy of the stream of plasma from the igniter. So since the velocity of the cathode spot on the surface is too much, there is a possibility of cathode spot to fly out from the cathode material, which may cause the problem in deposition. So in order to avoid the cathodic spot movement away from the substrate, it is away from the cathode material, it is very important to confine the cathode spot on the surface of cathode material. So there are different types of method of confinement of cathode spot on the surface of cathode. Of One of the most commonly used method to confine a cathode material on this cathode spot on the surface of cathode is known as passive or confinement. Dear student, in passive or confinement, we use passive material on the surface or at the end of the cathode material, which confine the cathode spot inside or on the surface of cathode. The passive or confinement may be represented by a schematic diagram as consider. This is a schematic representation of cathode in a cathodic arc deposition process. Dear student, please note that when the plasma arc igniter interact with the surface of cathode, the temperature of cathode become too much. It's become in 1000 degrees of centigrade. Please note that the arc igniter interact with a specific small surface of the cathode, which is known as cathode spot. So the temperature of that point will be too much. However, due to a very high temperature, there will be also a spreading of temperature over the whole surface of the cathode. So in order to decrease the temperature of cathode, the cathode material in cathodic arc deposition process is connected with water cooling system like this. So this is basically a wall representation of a cooling system which is connected with a cathode material. Since the spot is created by arc igniter on the surface of this cathode material, the arc will uh, the cathodic spot is created on the surface of the cathode material. So this cathode spot will travel across the surface of cathode material. So if the velocity of cathode spot is much, then there is a possibility that cathode spot just fly out of the surface of the cathode material, which may cause an impurity inside the reaction chamber and also impurity on the surface of substrate. So, dear student, this movement of the cathode spot on the surface of the cathode is avoided by incorporating passive materials like these at the end of the cathode. So passive material is material which have no effect on which the environment have no effect. So on these passive material, the effect of the effect of the temperature, as well as corrosion or any other environmental effect is less. So due to less effect, the cathodic spot is basically is confined on inside or on the surface of the cathode material in cathodic arc deposition process. Usually, dear students, BN ring or BN coils or BN rings, usually BN rings are used as a passive material in cathodic arc deposition process to confine the spots. BN rings are known as boron nitride rings. Okay. Apart from the passive confinement, the second type, students, second type of most commonly used cathode spot confinement is done by magnetic field, and this type of confinement is known as magnetically guided cathode or confinement. So in magnetically guided cathode or confinement, magnetic field is used to guide and confine the cathode spot on the surface of cathode. As I have previously discussed, that magnetic field of line interact with the plasma, which is a composition of ion, electrons, neutrals, and excited atoms, and due to their interaction they will basically confine the uh, the the cathode spot over the surface of cathode. Okay, the arrangement of magnets is very important because the arrangement of magnet will basically guide the confinement of cathode spot on the surface of cathode. So dear student, magnetically guided cathodic arc is known as steered arc. This means that with magnetic field the cathodic arc is directionally confined. By this we get particular trajectory of arc and also get trajectory on removed cathode material, including charged particle present in a plasma, cause uniform erosion and as well as uniform deposition. So in a simple word, this magnetic confinement play a vital role. It's not only confine the cathodic spot, but it also direct the eroded material onto the surface of substrate. So dear student, the magnetic field basically the cathode basically uh, guide the cathodic spot, and also it's guide the eroded material from the cathode to the surface of substrate. So dear student, when a directional magnetic field is applied across the cathode, that directional magnetic field direct the cathode spot with a specific trajectory onto the surface of cathode, and furthermore it also direct the material removed from the cathode spot to the surface of substrate. Okay, and due to this we basically get a uniform deposition on the substrate. So basically for confining the cathode spot, we need an arrangement near the cathode material. However, for directing and making a trajectory of the cathode material to be removed and transferred of onto the surface of substrate, we need a very specified directional arrangement of the magnetic field of lines. So they may be anywhere with a specific direction inside the reaction. The magnet may be anywhere with a specific direction arrangement inside the reaction chamber for making a trajectory of eroded material. However, for a cathodic spot, the magnetic field and the magnetic pole must be near the cathode. So now just let schematically represent that how the magnetic field of line basically confine the cathodic spot on the surface of cathode. Consider this is a schematic representation of cathode which is present in cathodic arc deposition instrument. Okay, since you know that when the magnetic field is applied on this schematic representation of cathode, magnet have north and south pole. The magnetic field of line come out from the north pole, and they are move and they go inside the south pole like this. Okay, so when the cathode spot is created on the surface of this cathode material, the cathode spot has different types of ion. It has plasma, it has neutral atoms and excited atoms. Okay, so all of these will interact with the magnetic field of lines which come out from north pole and go toward the south pole. So due to the interaction of the charged cathode spot with the magnetic field, the cathode spot will have certain trajectory over the surface of whole cathode, and in this way basically we can find the cathode spot on the surface of cathode in cathodic arc deposition systems. Cathodic arc deposition is a very important technique in microelectronic plasma arc welding and as well as composite industries. But there are some technical aspects which are basically there are technical problems. They are associated with cathodic arc deposition process, and these technical problems basically limit the potential application of cathodic arc deposition process, especially in microelectronic industry. Okay, the one of the most and very important problem with a cathodic arc deposition process is the formation of micro droplets. So, like if you want to prepare a thin film, you need a film in the range of few nanometer. But the drawback of cathodic arc process, deposition process, is that it gives you micro droplets or micro particle at different part of your deposited thin film, and these droplets will be non-uniformly distributed over the surface of your film. So this basically causes discontinuity or this makes the thin film dysfunctional, especially in microelectronic industry. Okay. What do you think why micro droplets are created on your film? The student, basically the micro droplets are created if the plasma or igniter stay for a long time at a specific cathode spot or at a specific point of the cathode, because this will cause a abrupt and very dense removal of cathode material, and due to a dense material the deposited material will be in the form of microdroplet. Secondly, the variation of speed of cathode spot over the surface of the cathode may also cause micro droplets. Apart from this, there is a possibility there is a possibility of change in physical and chemical composition of the material over the cathode surface. They may also cause the micro droplet, and there is and due to creation of micro droplet, there is also a creation of porosity on the surface of the deposited thin films. Okay, so basically, a student, these are the reason. These are the technical aspects which are basically very important to be considered in cathodic arc deposition process in order if you are going to prepare uniform thin film. Applications of cathodic arc deposition process. The student, cathodic arc deposition process is a very diverse process. It is widely used in microelectronic industry, aerospace industry, decorative industry, cutting tool industry. So it has a very wide diversity. So the potential application, here I'm on focusing on few applications which are very common for the cathodic arc deposition process. One of the most common applications of cathodic arc deposition process is that this technique provides the deposition of refractory materials and transition materials, and even we can produce a thin film of both refractory and transition material and their compounds. As I discussed before, that the refractory materials and the transition materials have a higher melting point, so it is difficult for the vacuum melt technique to evaporate them and deposit them as a thin film. However, the potential temperature of the plasma or igniter in cathodic arc deposition is too much. It's in thousands of degrees centigrade. They can easily cause the evaporation of refractory or transition material. So due to this, they may be easily deposited as a thin film. Another potential application of cathodic arc deposition process is that this process gives you an extremely hard resistive coating. Basically, it is a very resistive coating. This means that in case if you need in the areas where a hard coating is necessary, you can basically use the cathodic arc deposition process. So there are different types of hard coating material common, like titanium nitride, chromium nitride, titanium aluminum nitride, aluminum chromium titanium nitride, or titanium aluminum silicon nitride, etc. These complex types of hard coating are easily done by cathodic arc deposition process. Another potential application of cathodic arc deposition process is the coating of cutting and die casting material or die coating materials. Okay, this is done by these materials are basically coated by cathodic arc deposition process. Another potential application of cathodic arc deposition process is the aerospace industry and automobile industry. So like the automobiles and aerospace and space, like aeroplanes, etc., they need a hard, very adhesive coating, and due to this, cathodic arc deposition process is used in these industries. Cathodic arc deposition process is also used in defense and as well as medical machinery. So, in a conclusion, the cathodic arc deposition process is usually more common in refractory and transition metal industries. It basically provide a very because the temperature of transition material is too much, or refractory materials like zirconium, etc., is too much. So this process give you a diversity in evaporating those materials having high melting point. And apart from this, this technique gives you a kind of very hard coating. So this make its potential application in aerospace and automobile industry, and even defense and medical industry. So now let us summarize the cathodic arc deposition process. Cathodic arc deposition process is somehow similar with thermal evaporation deposition process. Thermal evaporation deposition process basically means the transformation of solid into a gas, then its transformation from a gas into a thin film. So both the thermal evaporation process and as well as cathodic arc deposition process are somehow same. In thermal evaporation process, the precursor material is heated either by resistive heating or either by electron beam evaporation, and it is then transported onto the surface of substrate. Whereas in case of cathodic or deposition process, the precursor material, which is a cathode, is ignited by using plasma arc igniter, and at the end of the day they are transported onto the surface of substrate thin film. Cathodic or deposition process is a low voltage and high current process. Cathodic or deposition process provides you a good possible stoichiometry of compound. So this process allow you to deposit a compound, though it is difficult, but if this process allow you to deposit compounds on the surface of the substrate with a different stoichiometric or different chemical ratios. Cathodic or deposition process allow to deposit the compound at low temperature. The evaporated material has a high temperature, but you can deposit that material onto the surface at a low temperature. The deposition rate of cathodic or deposition process is very high. Like in normal conventional processes like electron beam evaporation, thermal evaporation like closed space sublimation, etc., the deposition rate is low. But due to a high potential, or due to a high current, which is basically provided by arc igniter to the cathode spot, lead into increase in a kinetic energy of the removed material from the cathode spot, and due to this you will get extremely high rate of deposition at the surface of substrate. So this make the use of cathodic arc deposition in industry, because the industrial need a higher deposition rates of variable and large amount of thin film in a shorter time. So in that time they basically use the cathodic arc deposition process, and they prefer cathodic arc deposition process on the other available thin film deposition techniques. Cathodic arc deposition process basically provide dense coating and very adhesive and hard coating. As I previously discussed, the reason of providing dense, hard and adhesive coating by cathodic arc deposition process is the potential of removal of the plasma from the cathode spot by using the arc igniter, because the temperature of arc igniter is in thousands of degrees centigrade, and by its interaction with the cathode spot will basically cause the transformation of kinetic energy from the arc igniter to the cathode spot, which will lead into a removal of the plasma material with extremely high energy, and when it's interacted with the surface of the substrate, it's caused very good adhesion and extremely hard and dense coating. So plasma arc igniter give you an opportunity to deposit very thicker films, and also the deposition over the large surface area. Okay. Only this process has one drawback, and that is the creation of macro droplets, because the temperature of the plasma arc is too much. When it is interacted onto the cathode spot for larger time, it may create an intense amount of or higher amount of plasma density, and when it is evaporated in a continuous space, in a continuous fashion, this will basically cause a creation of macro droplet on the surface of your thin film, and these macro droplet may be continuous and may be discontinuous, which this is a very serious drawback. Basically this limits the application of your thin film, especially in microelectronic industry, because in that case you need a continuity in your deposited thin films. So this this is basically the summary of the plasma arc igniter plasma cathodic arc deposition process. In a simple word, cathodic arc deposition process is like a thermal evaporation deposition process. It's just use a plasma arc igniter to ignite the precursor material, which is substrate, and then it is transported onto the surface of the substrate as a thin film. Secondly, the plasma arc ignite cathodic arc deposition process provides you a very hot, intense, and thicker coating. So you, in case where you need a thicker and dense and hard coating, you can use the cathodic arc deposition process. The interesting factor to notice here is that this process provides you a kind of higher deposition rate, but the serious drawback with the cathodic arc deposition process is the deposition of macro droplet on the surface of your thin film, and these macro droplet may cause discontinuity, especially in microelectronic industry, and it may cause a mechanical problem like micro hardness or destability in the mechanical properties of your deposited thin film.